Hi everyone and welcome to day two of .NET Conference by CSharpCorner 2025. We had an incredible day one. We had about 7 to 8 different sessions. We had speakers from Microsoft. We had quite a few good community speakers, Microsoft MVP, CSharpCorner MVP joining us on day one. And I'm really excited to welcome you all on day two. For someone who's joining us for the very first time, I just wanted to remind gently about the code of conduct, which just simply means that be nice to the other attendees, especially in the chats and also all the conversations that we are having on social media. Just follow that code of conduct. And actually, please feel free to go ahead and ask any questions that you want to ask to the speakers. So we have about, I think, 4 to 5 sessions. It's a very light day. So if you feel asking any questions to the speaker, you can actually go ahead and drop it in the chats. We will either take it towards the end of the session, or maybe the speaker wants they can take it on the fly. With that said, we have quite a few folks joining us. We have Jose joining us from Brazil, Rohit from India. We have Sarthak here. Hello, Sarthak. We have Uno platform. We love Uno. Right, they're joining us from Canada. And we have Arun. We have Cap. We have Abori. I think Arif. We have Atul. Atul is my teammate. He's in Uttarakhand now. I'll be joining him the other day. Rohit says, "Hey Simon." So hi everybody. Welcome once again. I'm quickly gonna go through the agenda that we have. Today we're starting, it's 7 p.m. here in India. The first speaker that we have today is Chandu, is going to talk about Blazor. I still remember that even the other day we started with Blazor web development. So it's very exciting to start even day two with Blazor. Then we have Anuraj coming up with the lightning talk where he's going to talk about efficient containerization of .NET application. Then we have Kamran, who's going to talk about .NET Aspire, followed by Purnima and Alvin, who works at Microsoft in the Microsoft Learn ecosystem. And then towards the end, around 10 p.m. Indian time, we're going to close it. With that said, boys and girls, without any further ado, let's bring our very first speaker of the day. He is Chandu Shekhar. Chandu is a senior staff engineer. He's a Microsoft Azure architect and an enterprise architect. So, welcome, Chandu, to the .NET Conference 2025.
Hey, thank you, Simon. Thanks.
Thanks for your time, Chandu. I think we are connecting for the very first time. Are you willing to tell the audience who you are and actually where you're joining us today from?
Okay, sure. So this is Chandu, having more than 18 plus years of experience
Wow.
completely into the Microsoft technology stack. So I started my career from .NET 1.1 to the latest technologies. I joined from Hyderabad basically. So I'm working as an senior staff from an Fortune 65th company. Yeah.
Wow. Now that is super
So
cool. So yeah, that's pretty nice. 18 years is a long time. We were our team was there in Hyderabad. Just last week we were at CBIT. I think it's one of the colleges there, right? So we did a
uh,
hackathon there in CBIT. But 18 years is long. I remember I started my career with C Sharp with Windows 8 app development, that UWP and everything. That also old. That is also old. I'm not a legacy developer like you, but I'm not that.
No, no, no. I'm not a legacy developer. Currently I'm working on .NET 9. Completely
Wow.
into Azure. Yeah.
Yeah. Okay, that's pretty good. That's very good and so exciting, Chandu. I know it's at 7 p.m. here in India. So please
Yeah.
feel free to go ahead and share your screen. At the bottom, you'll
Sure.
find present. If you click on present, then share screen, and then you can select the screen that you want to present. And everybody in the chat, people says hi, Chandu. Everybody's in the chat. It's gonna be 35-minute session, and after 35 minutes, we
Okay.
can start the
Sure.
Q&A.
So I'm sharing my screen. So feel free to stop me. Uh,
All right, so I'm gonna add your screen to the stream. Everybody else can see it now, and next 35 minutes is all yours.
okay. Thank you. So today I'm going to cover, the Blazor part basically. So the topic name is Unleashing the Power of Blazor, the future of web development. That's what I feel. So, as I mentioned earlier, this is Chandrasekhar. So, currently working as a senior staff engineer for one of the biggest retail company. So you know, I'll start with the introduction of to Blazor basically. So Blazor is a .NET front-end framework that allows you to build applications using C Sharp and Razor components. So if you are familiar with the web development, we are hearing a lot of technologies like Angular, React, Vue.js, and different technologies. But with Blazor, we can develop the web application only with C Sharp and with the Razor components. And also we have the privilege, or we have the capability within the Blazor that we can interact with the JavaScript as well. So it's a powerful tool that enables you to create fast, interactive, and scalable web applications. So unlike other JavaScript based frameworks, Blazor allows you to write rich web applications entirely in C Sharp, eliminating the need to switch between the languages for back-end and front-end development. So we can develop the scalable applications, the web applications basically entirely in C Sharp. It combines the power of .NET with the simplicity of modern web development without relying on the JavaScript. So that is the biggest advantage of Blazor. And also, it simplifies the full stack development for .NET developers by allowing code sharing between the client and server. So it was introduced in 2017 by Steve Sanderson at Oslo. It leverages basically, the WebAssembly for client-side execution. So the Blazor, the name, the history behind it is a mix of browser and Razor. So reflecting its ability to run C# code in the browser, replacing the traditional server-side rendering within client-side approach. So this is all about the introduction to Blazor. So I would like to give a deep dive into the Blazor. Uh, so I would like to start with the key features of Blazor. So Blazor supports, or Blazor is a component-based architecture. So we can build the reusable UI components with C Sharp, HTML, and CSS like we do in Angular or React. We'll have the same sort of thing, like we can build the components. It supports two hosting models. I said two, but I mentioned three. I'll give you the history as well. Till .NET 6 or 7, we have a Blazor server and the Blazor WebAssembly. But in .NET 8 onwards, we are having the Blazor WebAssembly and Blazor hybrid. So the Blazor server is basically, it supports server-side rendering with real-time updates via Signaler. Whereas the Blazor WebAssembly is an the client-side rendering. So typically it works as in WebAssembly rendering, like the code whatever is compiled will be downloaded to the browser side, and from there it will operate. Whereas Blazor hybrid from .NET 8 onwards, it will have it targets basically the web desktop, the Maui basically I'm talking about. So as I mentioned, the Blazor supports the web development as well as the desktop development and mobile development. And also it supports the JavaScript interoperability, meaning that it integrates with the existing JavaScript libraries, as well as from JavaScript we can able to call the C# code as well. So when we are looking back into the history, like when we have ASP.NET, ASP.NET MVC, whatever we develop, somehow we rely on the JavaScript. Here also it supports the same sort of thing, but it's more into Razor and more into the C# kind of thing. So these are the key features of Blazor. So I would like to elaborate more on the component based architecture. So Blazor apps are based on the components. So a component in Blazor is an element of UI. Say for example, we can the button is a component. So any element of UI is a component, such as a page or a dialog or a data entry form. Whatever we'll call it as a component. Components are .NET C# classes built into .NET assemblies basically. So it defines the flexible UI rendering logic, handle user events, can be nested and reused. So the main purpose is, you know, reusability. So it increases the reusability if we create the components in an appropriate way. And also the component class is as usually written in the form of Razor markup language with .razor file extension. Razor is a syntax for combining HTML markup with C# code and designed for developer productivity. So see here, on the right hand side, I mentioned, the code basically, at the rate code, and then we are writing the methods that can be invoked. See here, the increment count is a method that is being used at on click. So, this method is being called here. So the components render into an in-memory representation of the browser's documentation, that is DOM basically, called render a tree, which is used to update the UI in flexible and efficient way. Okay, so this is all about the component based architecture. So now I would like to go into the hosting models. So as I mentioned, one of the hosting model is Blazor server. So it supports hosting of the Razor components on the server in an ASP.NET Core environment. So assume that this is the server, and we have the ASP.NET Core here, and resides that we'll have the Razor components. So these Razor components basically will be rendered as in DOM, but the interactivity will be happen through Signaler. So here I'll go into deep. So the UI updates and event handling and the JS calls are handled over Signaler connection using the WebSocket protocol. So in a way, it's a blessing because the end user doesn't know that something is happening, so it will give an single page application uh, kind of feel to the end user, but internally it uses Signaler and it will communicate through WebSockets protocol. The runtime stays on the server side and executes the application C# code and sending the UI events from the browser to the server, and also applying back the UI updates to render the component that are sent back by the server. So the changes will be applied on the DOM side, but the communication will be happened through Signaler in Blazor server hosting model. So when a Razor page or a view is rendered to the browser, every line of Razor code emits the HTML in text format, so that it will be rendered. The HTML will be rendered on the DOM side or the browser side. The Blazor produces a graph of the components. So all the components that are rendered as an HTML will be rendered as a graph of the components to display on to display basically similar to HTML or the XML term. A component is disposed after the user navigates to another page. So to get the memory optimization, so whenever we are navigating from one component to another component, the it will dispose that particular component which is being rendered. So after the UI components are interactive on the UI, and the UI updates are triggered by the user interactions and the app events. When an update occurs, the component graph is rendered. I already mentioned, and also the Signaler. Basically, everybody knows about the Signaler, but to be to be on the point here, on this context, Signaler is a powerful library developed by Microsoft, and that seamlessly incorporate real-time functionality into applications. So it allows you to push content from the server to connected clients in the real time. So that's how the Signaler works. So now I'm going to Blazor WebAssembly. So the Blazor WebAssembly is completely a different approach from the Blazor. So Blazor WebAssembly is a single-page application framework for building the interactive client-side web apps with .NET, and running .NET code inside the browser is made possible by WebAssembly. As I mentioned, so whenever in WebAssembly project is application is built and run, four things will happen. The C# code files and the Razor files are compiled into .NET assemblies, and those assemblies will be downloaded to the browser. And Blazor the Blazor WebAssembly bootstrap the .NET WebAssembly runtime and configures the runtime to load the assemblies for the application. So everything will be bootstrapped and downloaded to the browser. The runtime uses, so here it is not like Blazor server app, but here the way it works is the runtime uses the JavaScript interop to handle the DOM manipulations and browser API calls. And Blazor WebAssembly optimizes the payload size to reduce the download times. So if you are building an very big application, the download time will be huge. So to reduce that, basically what they are doing is unused code is stripped out of the app when it is published by the IL trimmer, and HTTP response are compressed. The .NET runtime and assemblies are cached in the browser. So this is how on a high level it's all about the Blazor WebAssembly. So I think I'm good. So any questions for me? Okay, fine. So now I'm going to the Blazor hybrid. So it is from .NET 8. This functionality, or this one is coming from the .NET 8. So Blazor hybrid enables using the Razor components in a native client app with a blend of native and web technologies for the web, mobile, and desktop platform. So basically, the code runs natively in the .NET process and renders the web UI to an embedded web view control. So WebAssembly isn't used in hybrid apps, but it uses, you know, it the hybrid apps are built with .NET MAUI, which is a cross-platform framework for creating native mobile and desktop apps with C# and XAML. So Blazor Hybrid supports WPF and Windows Forms to transition applications from earlier technology to .NET MAUI. So it particularly well suited for the building the applications that needed to run both desktop mobile platforms. So this is all about Blazor Hybrid. So I'll talk about you know benefits, limitations, and challenges, but I'll come to this slide later point of time. But I would like to cover the reasons to adopt Blazor. Okay, so the Blazor offers unified development language. So Blazor allows you to use C# for both front end and back end development, reducing the need to switch between the languages. So Angular, React primarily uses JavaScript, TypeScript, which might require additional learning for a .NET developer. But if you are developing the application using Blazor, you doesn't need to. You can develop the web application with the help of C#. And also, it offers seamless integration with .NET. Blazor integrates, deeply with the .NET ecosystem, making it easier to use existing libraries and tools. This can be streamlined development process for teams already using .NET technology. So it offers seamless integration with the .NET, and also it offers component reusability. So Blazor components can be reused across different platforms, including web, mobile, and desktop applications through .NET MAUI. And also, the Angular and React. When it comes to Angular and React, it also supports the component-based architecture, but may require different frameworks for mobile and desktop. But if you are developing an application targeting cross platforms with the help of .NET MAUI, we can develop the applications to support the cross platforms. And when it comes to the performance improvements, like the Blazor WebAssembly has significant performance enhancements with the .NET 8. I see as in I'm past 2 years or 3 years I'm working on Blazor. So with .NET 8 I'm seeing a lot of enhancements. Uh, so including the reduced app sizes and faster load times. Angular and React have their own performance optimizations, but may not benefit from the same level of integration with .NET. So these are the four reasons I mentioned as the main reasons to adopt the Blazor. So when to adopt the Blazor? So we have Angular, we have React, and we have legacy applications. So it is very important to know when to adopt the Blazor. So if you are having an existing .NET infrastructure, then it is better to adopt Blazor to modernize your application. So if your organization has an already has a significant investment in .NET technologies, adopting Blazor can leverage existing skills and infrastructure. So and also the full stack development, as I mentioned, through C Sharp, uh, we can develop both front end as well as the back end code. And also this is also I mentioned, like the cross platform application support with the .NET Movie. We can able to develop the cross platform applications and also the real time applications. So if you are looking into the Blazor server, it communicates from client to server using Signaler, right? So it is well suited for the real time applications where server side rendering and the constant server connections are beneficial. So and the long term project. So if you are going with Angular or React or any other open sources, like will the maintenance will be heavy because we may develop using few libraries. Those will be obsoleted at one point of time, and yeah. So as it is .NET, uh, as it is an fully built on top of the .NET, and we have a Microsoft community. So for long term projects, it is suitable. So these five factors I mentioned, based on these five factors, we can adopt the Blazor. And the technical highlights, basically, I would like to highlight, like Blazor supports standard DOM events, like on click, on change, and it also supports the custom events. So the supported events are mouse events, keyboard events, form events, focus events, and clipboard events. Like here, I mentioned all the mouse events, keyboard events. So the event types, say for example, we have a button and we have an event called onClick. So we'll mention @onClick and that particular method name, and in the C sharp code, we'll write the particular logic. So this is how we'll handle the events. And the validations also, it is pretty much easy. It supports the data annotations. So we'll open a tag edit form and we'll bind the model, and we'll mention on valid submit, basically. So where we'll call the data annotations to validate that particular model which we have bind. So in the validation summary tag, we'll get the validation error. So we'll have different validations, right? The required range, all other uh, data annotations will be supported by Blazor. And we have JS interruptibility. So Blazor allows calling JavaScript from C Sharp, vice versa. Like from C Sharp also, we can call the JavaScript. From JavaScript also, we can call the C Sharp method. So will Microsoft provides IJS runtime to invoke JavaScript functions from C Sharp. Say for example, in the code we can write JS runtime, invoke async, and then the method name, and we'll pass the attributes. If you want to call the C sharp method in JavaScript, on top of the method, we need to add JS invocable attribute. So in this way, we can call the JavaScript interoperability. So when it comes to third-party tools, so the other advantage I am seeing is, we have a lot of components, open source components that are available in available for Blazor. So we have MudBlazor, Radgen, Microsoft tools. These three are basically the key players which are offering very beautiful and user friendly components. So Radgen and Mudblazer are widely used, and Microsoft is started giving the are building the the components for the Blazor. So I mentioned the links. I don't want to open them, but yeah, let me open one. So in Mudblazer, see we have different components that are here. So all these are different components that when and that we can use them directly by using or by invoking that particular Mudblazer library or the NuGet package into our project. And also, uh, yeah, before conclusion, so I would like to cover the benefits, limitations, and challenges part. So I'm comparing the Blazor server app, Blazor WebAssembly, and Blazor hybrid. So I would like to talk about the benefits of Blazor server app. So uh, Blazor server app basically it is fast initial load times. So it is not like WebAssembly. So it will start the application very fastly. So the initial load times is less when compared with Blazor WebAssembly, and the download size is significantly small when compared with WebAssembly, and the server side execution reducing the client resource usage. When it comes to the benefits of Blazor WebAssembly, runs directly in the browser, offline capabilities. Whereas in the Blazor server app, we don't have the offline capabilities. Every time the signaler communicates with the server, it uses the C Sharp instead of JavaScript. So these are the major benefits of uh, WebAssembly. So when it comes to Blazor Hybrid, it offers the cross-platform support, mobile, desktop, and web, and also it offers full access to native device and capabilities, the reuse of web UI components across the platforms. So those are the main benefits of Blazor Hybrid. When it comes to the limitations, uh, as it is as Blazor server heavily depends on the signaler, we'll have a higher latency due to network ops. So for every user action, it will try to communicate to the server through signaler, so which causes higher latency due to the network ops. The scalability concerns with the many concurrent users. So if you have concurrent users, definitely the network latency will be high, and we'll have the at least I have seen these scalability concerns, and it requires constant server connection. So if the server is down, unlike WebAssembly, it won't offer the offline capability. When it comes to the limitations of Blazor WebAssembly, the larger initial download size. So it will give an uncomfortable or the unuser friendly experience to the user. So larger initial download size is one limitation that we cannot avoid, and also the restricted to browser capabilities. So as it is the WebAssembly advantage is offline capabilities, but somehow it will restrict to browser capabilities. So if the browser is not supporting some capability, the Blazor is also not supporting that particular capability. It's a restriction basically, and also the performance issues with the complex C# code. So if your program has a lot of complexity on the UI, on the user interaction, so it causes the performance issues. And also the limitations of Blazor Hybrid is the separate native client apps must be built and maintained for each platform. So for web, so we may have the same components can be used in different cross platforms, but we need to maintain them separately. Platform dependent components and styles also giving maintainability problems, and longer download and install times compared to web apps. So it is uh, you know It offers longer download and install times. The challenges I have noticed with the Blazor server app is the connection stability in poor network conditions, because it requires the constant server connection, right? So the connection stability in poor network conditions is a challenge, and server resource management for multiple users and uh, and handling temporary network interruptions will be a challenge. And Blazor WebAssembly, so initially we'll see the slow initial load times, deployment issues like file corruption, and also the compatibility issues. So when it comes to Blazor Hybrid, the managing the real-time and large-scale data is a challenge, and optimizing UI rendering for large data sets is a challenge, and offline support and data synchronization is also a challenge when we adopted Blazor Hybrid. But apart of all these things, it has reasons to adopt, and it has you know uh, cases when to adopt the Blazor. So on conclusion side, like Blazor unifies web, desktop, and mobile development for .NET developers. It is mainly for .NET developers. It simplifies the .NET developer life to develop the web applications, and growing the adoption and Microsoft backing fuel its moment. A key player in shaping the future of web development. So this is all about Blazor. So any questions for me?
Thanks, Chandu. That was a very crisp session. We have a few questions in the chat. Let's take them because we have about 10 minutes before we move to the next session. The first one coming
Okay.
from Ledger says, "Hello from Africa. Hi, I know he's a maybe I can see up there. So maybe let's take first from Sharma Sakshi. She's asking, I think she's a Gen Z. She's asking, what are the biggest advantages Blazor offer over traditional JavaScript framework like React and Angular? I love React. I don't mind working with React.
Right. So if you are a C-sharp developer, so you no need to learn JavaScript or TypeScript, anything. You can directly develop the web application, and also it has a backup of Microsoft, so the maintainability is very easy. And also, unlike the React or Angular, we have very standard or very good community support. So, like I mentioned, the Mud Blazor or the Radzen. See, we have multiple components that are available. So, you can able to build a complex web application directly by consuming those components.
Yeah.
So I say, it is very easy for .NET developer to develop a web application. That is one of the biggest advantage. And the second advantage is, the components that has, that Blazor has, and
Yeah.
the maintainability. Yeah.
Yeah, that's right. I mean, I'm with you when you say, it's a piece of cake for folks who are already into the C sharp and .NET ecosystem. They don't
Right.
have to learn anything new. But if you are not in the Microsoft ecosystem, right, and then you think of learning Blazor, that might have a learning curve, and you might feel like, why are you using C sharp, and that may be a little obstacle, right? Maybe is stopping you to learn Blazor. But yeah, if you are working on C sharp.net, then why not? Right? There's no
Yeah.
harm in trying. Okay, perfect. And there's another question coming in from Rohit. He's asking, what are the biggest challenges you have seen teams face when adopting Blazor, and how can they overcome?
So that's a very big, question. So, the challenge, yeah, the challenges we noticed is, choosing either Mudblazer or components creation basically, and educating the team, right? So no
Yeah,
one is everyone is new to Blazor, so educating them, and we have learning curve, but for a .NET developer it is pretty much easy.
yeah,
But while adopting the Blazor, the we have seen, like whenever we have a poor network connectivity, right? So it will always pop up saying that it is disconnected, when we develop the applications using the server app, because it continuously poll the server with the help of Signaler. But
Mm.
on a high level, I haven't seen any challenges. We are using Telerik basically, the Telerik components. Okay, so as we are using the Telerik components to build the enterprise application, so we haven't seen any uh, major challenges. But we are enjoying developing the application with Blazor because it is pretty much easy when compared with the React or the other things.
Yeah, yeah, that is right. That is definitely right. And one thing, that always confuses me with Blazor, and I don't know why it is with Blazor. I know people like to compare, Blazor with React, Angular, Vue. When you work with these, JavaScript, libraries or framework, you want to call it, um, there's only one framework is there. For React, it's only React. For Angular, it's only React. But for Blazor, you gotta decide: is it a client side one or is it a server side one? So why do Microsoft has two flavors of Blazor? I don't get it.
That is true, but yeah, that is true. But if you are trying to achieve or develop a single page application, the
Hmm.
Microsoft document clearly says that we need to go with WebAssembly. If
I
you are
see.
targeting multiple platforms, you know the Microsoft documentation says go with .NET MAUI with Blazor hybrid. Okay, so
Mm,
if your application requires multiple interaction support, then go with Blazor server app. I see lot of people adopting WebAssembly and
yeah.
.NET MAUI rather than
Yes.
server app. Yeah,
Yeah, yeah, that's right. WebAssembly is more popular, right,
right.
than this app. That's very right. Okay, we have a few more questions. There's another one coming from let's say Prahlad Chai is asking, do you see Blazor eventually replacing JavaScript framework? I don't think that's gonna happen in enterprise environment. Or do you think it will complement them? I don't think so. It's gonna take place.
No,
Yeah,
JavaScript won't be replaced by any other technology,
yeah,
right?
yeah. And
So end of
yeah,
the
and if
day,
I'm not,
the
yeah,
pro- right. So end of the day, the browser understands JavaScript. So if you
yes, I
develop
was
your
about to say.
application, in any other language, whether it's in Python, Java, whatever, end of the day, the browser understands HTML, CSS, and JavaScript.
That that is
So
that is 100% right.
right, yeah,
So if I'm not wrong, right? Correct me if I'm wrong, right? The C sharp code that you're writing, that is at the end of the day, is getting converted, translated into JavaScript anyway, right?
right,
So yeah, no, nobody's getting replaced. JavaScript is not getting replaced. Don't worry about it.
yep.
There's the one from Nikita. She's asking, what are some common architectural mistakes developers make when starting with Blazor? Ooh, is there any architecture, framework or something that's there up there that people like to follow? I know there's a project structure some people really like to follow, right?
Right. So, as an industry standard, we'll follow the clean architecture framework.
Hmm.
So, I haven't documented that, but as a practice, we'll follow the clean architecture framework.
Yeah, simple and straight. Let's just stick to that.
Yeah.
All right. I think there's a few more. There's a Jose is asking, would you recommend obfuscating the Blazor code that will run in browser for security reason? I can't spell that. I can pronounce
Okay.
that word.
So, right. So, for security reasons, right? So, I'll tell you, uh, we integrated multiple security scraps within the CI/CD pipeline.
Hmm.
Uh, Okay, so like the industry standards, like the Black Duck scan, the Vera code scan, Sneak. We integrated all of them when we developed the applications in Blazor, but we haven't seen any security vulnerabilities when we develop the application with Blazor, right? So we'll have a feeling that it is as it is downloaded to browser side, it may cause security reasons. No, it won't.
Perfect. Okay, makes sense. Makes sense. We'll take one final question and then I'll let you go. I know it's already maybe dinner time. There's a question coming from Abodi, he's asking, it's an interesting question he's asking. Is Blazor only dedicated to Microsoft technologies, or it is used in several websites? Because I don't really see it in demand. Well, if you're in the Microsoft ecosystem, you'll hear about Blazor often, right? But not really
Yeah,
outside.
yeah. You answered that, Simon.
Yeah.
Yeah,
Well, that's one thing. Okay, I think maybe we have a few more, but I think we'll have to skip it because we're running uh, out of time. But thank you so much, Chandu. Right? Thank you so much for
yeah.
joining us. I think we're hosting it you for the very first time. So I'm so glad you gave us your time. Any final thing you want to add before we move to the next session?
No, thank you so much, Simon, and thanks, for giving me this opportunity. Right? Thank you so
Yeah.
much.
Well, thanks to you for giving your time. I know it's evening here in India. So have a nice
Yeah.
evening and have a good dinner. And let's stay in touch. And maybe I'll see you in some other events. Thank you.
Yeah, thank you. Yeah.
Thank you. Bye bye. All right, ladies and gentlemen, that was Chandu for you talking about the Blazor. It's so always good to start a day talking about Blazor. We started about Blazor the other day, and so did we today. And with that said, we now move to our next session, which is a lightning session by Anuraj. Anuraj is going to talk about, if I just pull up my the agenda day two. Anuraj is talking about efficient containerization of .NET application using .NET Publish. We have 2 minutes before his session starts, so I'm going to quickly play a minute video, and after that video ends, it will be me and Anuraj up on the stage. See you soon. Well. Hi, Anuraj. So good to see
I
you once again.
yeah, say
So before we talk about anything else, I know we have just about 30 seconds. I want to talk about how was your US trip to the MEP summit. I saw some
yeah, it
great
was awesome.
pictures.
It was awesome. It was awesome. It was good.
Great, great.
Like I was able to meet like legends like Dave Powell, Scott Hansen, man, and it's
Wow,
awesome.
wow. Wow. Did you get a selfie with Scott Hanselman, the most
No,
popular
this
guy?
time no. No, this time no.
Okay, okay. All right, and Raj, you have a 15 minutes crisp session coming
Yeah,
up. So please feel free to share your screen and
sure,
then I'll
sure.
add it to the stream.
Yeah. Okay,
Yeah, it's loading on my
you're
end.
able to see my screen.
Yeah, I see your slides. I've added it to the stream, and next 15 to 17 minutes is all yours.
Yeah. So hello all. So this session is about efficient containerization of .NET application using .NET Publish. So my name is Anurag. I'm a Microsoft MVP. So first of all, why we need to containerize .NET application? So basically, when we are uh, like developing and deploying application, earlier we used to mind, okay, if I'm building a .NET application, is my host also contains the same version of the .NET installed on that machine? Or some, if we are using some other dependencies, we have to make sure that dependency is all already installed on that machine. So all those problems we were able to fix with a Docker container. So when Docker introduced or containerization introduced in .NET Core, we were uh, we can just build the application and containerize it, and we will be able to deploy it to the source. So basically, when I started my career, I used to like say, okay, it works on my machine, and my manager and lead used to say, okay, we are not shipping your machine to the client. So Docker actually solves that problem by pulling everything, abstracting everything into one, or encapsulating every dependencies, everything into a single unit, and you can deploy that unit. So these are the various reasons why we need to content it. We'll be able to port the applications very easily between various environments. We'll be able to scale. So, for example, if I'm running an application in container, I'll be able to scale it. Like say, I want to run 5 instances of that application. I can just say, okay, my scale value is 5. Then I'll be able to run it in 5 different environments, different instances. And it's same line. So as a developer, I can focus on okay building the application, and I don't need to worry about okay in my server that dependency is there, or the same version of .NET is installed on that machine. All those things I don't need to worry. So when we starting like container, we need to understand okay what all things we need to. So we need in the traditional containerization, these are the challenges. So when we are developing a container, you need a specific file called Docker file. So it is a set of instructions. What all things you need to be part of that container image. So it is manual process. Or like if you are using Visual Studio or VS Code, you will be able to generate it, but still there are some challenges. For example, I am building a web API application, and I am adding I created a Docker file, then I am adding a library as a dependency. Then I have to modify my Docker file to adjust that also. I need to copy that. I need to update the build steps to build that assembly, all those things. It should be again updated. That is one issue. Second is uh, we we will be like we have to make sure that container runtime is installed on my machine. So if you're using Docker or Podman or any other container runtime, we have to make sure it is installed. And since this is a virtualization technology, either you have to install like this one, a WSL, or virtualization, Hyper-V. So all those things matter. So that we have to enable virtualization in your machine. If it is not supported, you won't be able to do that. You have to enable WSL, all those things. And in CACD, uh, we have to configure more steps for adjusting the again Docker has to be installed on the CACD pipeline, all those things, and steeper learning curve for beginners. So if you're a .NET developer and you have to learn one more thing, like you need to understand YAML, you need to create Docker files, you need to understand some like basics of Linux, and what are base images, how layering works, all those things. It may be a little overwhelming for a newcomer, but it is that. So how uh, .NET team or Microsoft .NET team resolve all these issues in from .NET 6 onwards, they introduce a new capability. Uh, we can publish Docker uh, images, or we can create Docker images without any uh, container runtime support. We can use the .NET publish command to create a Docker image without any support. So no Docker file container runtime is needed, and it's very simple. You just need to say Docker. You can create a project and say Docker publish with the default profile command to say. And if you want to customize the uh, Docker image settings, you can modify the project file and update. So these are the prerequisites. You need .NET 8 SDK and container runtime. Again, it's optional. If you already installed it, good. If you want to play around and you want to test it or uh, like uh, run in locally, all those things, you need Docker or a Boardman or any other container runtime. Let's jump into a demo. I already created an .NET Web API application. So it's nothing, just plain or .NET Web API application, minimal API. And then uh, I am already running Docker in my machine, but I don't have any images. I don't have any containers. So I am just going to execute this command. Publish. Uh, this is everything is .NET 8. It works from .NET 6 onward. So it is building an image, hello world, that is the project name. With the tag. Tag is basically version kind of thing. So tag latest on base image Microsoft uh, .NET ASP.NET. That is the like base image. From that, it is actually the kind of kernel for that image. Now, if I say Docker go here and images, you will be able to see it created an image. Let's run it. Docker run. See. So it started at web server listening on port 80. I don't have any like uh, IAS or any other thing working on my machine. So it is working in Docker host. And let's say again, now you'll be able to see, okay, this is warning I'm getting, but this is actually working. Let me modify that log, that log, and typing a log and shutting down the application and publishing it again. Now, if I run this again and browse again, you will be able to see that log. So, this is the way we will be able to publish the uh, content or create documents. Now, uh, there are certain things. All these things are running on my machine. But sometimes, if I'm publishing to a uh, hub or Docker hub or any container registry, so Docker or container workflow is basically you create a container, you publish it to a container registry, and your ops team or deployment team fix that image or your whatever CI/CD pipeline fix that image and deploy to the web server. Of in natural it is Azure Container Registry and like Azure Content Bank. That is the offer. So if I want to publish to Docker Hub, I'm not using Azure Container Registry. I'm using Docker Hub. So in that scenario, I have to make sure that my container name instead of hello world, it should be in the format of Docker Hub username slash the image name, application name. So if I want to customize that, I just need to add a property like this, container repository. This is my Docker Hub username, and this is the application. And now if I do this, oh sorry, I didn't save the file. Now it builds a different image. So I'm just Hello with the latest. Okay, now if I come here, you will be able to see Android Hello. It's the same thing, no other differences. And uh, keeping the latest as version is not the recommended practice. So if I want to customize the tag, I can do it with the container image uh, tag, container image tag element. So here, these are the various customization options. So I'm changing, I added a version as V1. I'm keeping these things are value. Then I'm publishing again. Now it came as V1 tag. Earlier it was slated. Now it is V1. And so, okay. So if you look into this, you will be able to see Debian. And if I want to, and it's almost 220 Mbps, 220 MB. So if I want to reduce the size of that image, I can use Alpine image. So I'm just changing it to Alpine and I'm updating the tag as well. Now if I run this again, change, and if I go here, that Alpine version was a smaller footprint. So it's only 110 MB and it's Alpine. So these are the various ways you can customize. And all these things are published to my local registry. If I want to publish it to a different one, what I can do, I can like add a container registry, which is the container registry you want. You can set it. And giving the yeah. Okay, this is the way you can run the container. And for deploying to Docker Hub, you need to set these two environment variables. Container is the username and password. So set those environment variables. Mm, Now I set those environment variables and I'm updating. Mm, Let me This is Dr. Hub. I don't have any hello world or anything. So here I'm commenting this. Um, I am publishing again. Now hopefully it will get published soon. Yeah, it is actually getting published to the Docker Hub. You will be able to see it here. Yeah, these are some best practices. Uh, as well. Now, Docker Hub is not bad. So these are some best practices we can follow. Use physical tags always. Don't use status mode to the image size. So you can optimize the Alpine or any other images. You can do security scanning, regularly scan images for vulnerabilities. So there are, yeah, this got up deployed to the Docker Hub. So there are some tools available for security scan. Yeah, these are some resources which help you to learn more about it. And thank you. Simon,
Bang on, you're on time. It's 7:59, just a minute before we move to the next session. I know, I know. We were saying that we're not going to take any questions, but let's take at least one question, right?
yeah,
People,
yeah,
maybe you can come back to the YouTube live on chat, and then maybe you can reply to some of the questions, right?
yeah.
So maybe let's take there was one from one of the MVPs. So where did it go? Yeah, Sarthak is asking, is .NET containerized app containerized app? What's the best practice to simplify CI/CD pipeline setup when Docker dependencies complicate cloud native builds? That's
Yeah.
too
So
many jargon
uh,
ones.
this one, this is actually a deployment. So I'm just deploying my application to again Docker Hub. So it's nothing. I'm just setting up .NET SDK and build or deploy everything to Docker Hub. Nothing. I just need to run this. It will like unless I configured, I can manage. Yeah.
So we
So
don't see
I'm
your
just
screen. Just in case you were showing your screen, we don't have your
yeah.
screen up.
One sorry. I, yeah. So I just there is a like hello.net. It is in my GitHub repo. So I configured a GitHub action. So basically, in this thing, I'm just setting up .NET SDK and I'm just publishing. That's it. Simple. No, no other configuration or anything. It is not suitable for all, but most of the like CI/CD, or most of the application containerization works with it. And .NET Asper is using this technique to build and run all these like whatever container uh, like unless you are saying as Docker file and you are using Docker file to publish that as a part of your application. Uh, by default, .NET Asper is using this technique for building images container sets.
Perfect, perfect. Thanks for answering that questions, and I think that allows us to now move to our next session. And Raj, any final thing you want to add before we move to the next session?
No, thank you. Thank you for the time. Thank you for like attending my event like session. Thank you. Please
Yeah,
feel free to ask or connect offline on it. Thank
yeah. Please feel free to go and connect with Anuraj. He's pretty active. I also have one of his book here somewhere. It's up there.
you.
That's how I got connected to Anuraj. His
Yeah,
his book is there with
thank you.
me. So thank you so much, Anuraj, for your
Thank
time.
you.
Have a nice evening, and yeah, hope to see you soon. Some in some other in-person
Thank
events in
you.
India.
Bye.
See ya. Bye bye. All right, ladies and gentlemen, that was Anuraj giving you a very crisp and short session, just about 15 minutes. And now we move to our next session, and that's by Kamran. Kamran is actually going to talk about uh, .NET Aspire getting started. And Kamran is a senior C Sharp and .NET developer. He's a CTO, he's a C Sharp mentor, and a software engineer. So without any further ado, Kamran, welcome to the .NET conference. I cannot add you because your device is disconnected. Perhaps you need to switch on your camera. That's how I can add you. Kamran, if you can hear me, you'll have to switch on your camera. I think that's only I can add you. Your camera was working fine moment back. Sarthak says, thank you. Come on, don't do this. Don't ghost us. If your device is not working, maybe you can just refresh your page and maybe just come join this meeting once again. And until then, we'll take a minute break, ladies and gentlemen, and we'll see you in about a minute. There you go. Now I can add camera. Let's see if the magic works. Do loading, loading, loading. Cameron, can you hear us by any chance? That's interesting. At half an hour. Well, some technical glitch is so much needed in a virtual conference. Well, it did work very nicely. Okay. Pravesh says, thank you, Simon and Raj. And for those, while we figure out how Kamran joins us for the for the next session. I wanna quickly share my screen. Go to entire screen and yeah, hide it and add this one. Yeah, I want to talk about the upcoming conference that we have, ladies and gentlemen. The next conference that we have coming up is in August, right? The dates are actually August 5th and 6th. This is, I believe, this is going to be this is going to be the fifth edition of Soft Architecture Conference. Last year, I think we had incredible 3 days. Uh, Right, we have about 30, 40 speakers. It was a very, very, very good conference. We do this every year. Ooh, some CSS issue. And yeah, we had last year we did it on August 14th, 15th, and 16th. And this year we're gonna do it on August 5th and 6th. And if we get good submissions, then we'll move it to maybe 3 days of conference. Let's try to add Kamran. Cameras is still not working, but never mind. And if you go to the new C Sharp platform that we have.
Okay,
Oh, there
great.
you go. That's my man.
Yes.
There he is. Hello, gentlemen.
Uh,
How are you?
great. Thank you. And how are you? Sorry.
It's okay.
Thank you for.
There's always something that happens, right? So where are you joining us today, Kamran, from?
I'm from Iran, and
Wow.
yeah, as you mentioned, in Iran, it's really usual. I mean, when
Are
we
you on
have a few,
VPN by any chance? Are you using VPN?
now I connected my VPN, and
Yeah.
it's okay.
Yeah, I think we had a couple of speakers. I think maybe from Wahid was there. I think he also had the same issue. So some speakers tried to connect it on VPN, then it works. Kamran, thank you so much, Kamran, once again, for joining us in this conference. We really appreciate your time. Please feel free to go ahead and share your screen. I know we're already some minutes in your session, so please feel free to go ahead and share your screen, and then we can get started.
Okay,
Yeah.
great. Yes.
Um,
So,
I have added your. Oh wow! Are you gonna present through your website?
yes, starting from
That's
here,
pretty cool. All
this
right, then
one,
next, the floor is all yours, and next 30-35 minutes is all you.
great. Thank you so much. Great. So, as you know, my name is Kamran. I'm a software engineer. But before that, let me tell you that this monitor is the StreamYard, and this is my laptop, which I'm going to present on my laptop and Visual Studio and other stuff. And my notes are here. So if I'm looking at this uh, monitor, please excuse me because I should check the chat and comments. So let's get started. My name is Kamran, and I'm really happy to be here as a speaker for the uh, .NET Aspire new feature of Microsoft, which that's really exciting feature. So in this session, I'm going to dive into how to enhance an existing .NET project by adding the .NET Aspire. So why I'm not going to introduce .NET Aspire or getting started by .NET Aspire, because if you do a little search on the internet, YouTube or anywhere, you will find many resources which all of them are talking about how to get started. I mean, how to create a new project in with Aspire. Okay, but in a real world, we are not going to start from scratch. Uh, all companies, they have their own projects, right? And they are working with clean architecture, microservices, and layer, or even simple web API, MVC Blazor, or any other applications. They're not going to delete their projects and start from scratch. So the big deal is, how can I integrate or add this new feature, .NET Aspire, to my existing project? This is better than starting from scratch. So, for example, for a sample, I have created a project, and as you can see, this is my blog on GitHub.io, and this is my website, which most of the time I'm working as a mentor for finding a job offer. It has many steps. It's not really easy, which you can take a look at my website and see what we do. I'm not alone. We are a team. So, but if you want technical uh, blog, this is my blog, and you can see my articles. Also, I have a YouTube channel which you can see my YouTube channel at this address, which I uh, teach whatever I learn. I'm same as everybody else. So, as you can see here, I have a project, a web API project, which is uh, implementing a CRUD operation for a really simple entity called person, which has an ID, first name, and last name. It doesn't matter, you can add more properties, more fields to entity, or you can have many other entities. It doesn't affect on what we are going to do. And I have my database context here. I have the controller, which implements the uh, showing the list of people, uh, showing one person by ID, updating, creating, delete, and other operations. So, and one more thing that I'm going to show here is the connection string. It's my connection string. And let's see what do we have in the program.cs. The regular things that we usually use in our projects. Controllers, API versioning, and using Swagger, and registering the database and the other stuffs, routing, mapping controllers, and others. And another project that I have is an MVC client project. That's an MVC which acts as a client, and its responsibility is showing or interacting with my API project to make an interface for, uh, let's say, our application. So if I need to run the application, uh, I need to run multiple projects because I need to run both projects at the same time. And then when I press the run button, let me see where it's going to start. Yes. Okay, great. So you can see that I have two projects starting. One is for my API project, which is loading on 5001. It's my API project. And another one is my client application, which in this case, it's an MVC application. So, of course, you know that there are other solutions like using Docker Compose for converting my application to Docker image and running them through Docker. But here we have something like .NET Aspire, which it helps to manage, run, log, monitor, and many other features to make it easy our lives. So In my project, I'm using API, MVC, EF Core as my ORM, but we are going to convert this project to an Aspire project, or let me say, uh, add Aspire to the current project. So, okay. We're going to talk about what is Aspire and how it helps to developers. We are going to add .NET Aspire to an existing project using Visual Studio, of course, and we will see how to use pre-built packages in .NET Aspire. Of course, Microsoft provides some packages, but they're not complete yet. I mean, uh, we need more packages, but of course, .NET Aspire is new, and we need to wait for other tools to integrate with .NET Aspire, and we will see how we can use other tools and technologies that are not integrated with Aspire using container for unsupported tools. And then I will just mention how to use Postgres instead of SQL Server. I'm using SQL Server as a database, but at the end I will add the Postgres as a database to see how it works. So let's see, what do we have here? Let me stop the projects, and let me show one more thing uh, from my MVC client. Of course, I have my controller, which, as you can see, it represents or returns views for listing people, for showing the detail of a people, creating and update, delete, and other stuffs. So, and one more thing is service. I wrote a helper, generic HTTP service, to communicate with my API with HTTP calls. And as you can see, I'm using HTTP client factory here. I have methods like post async, get async, delete, update, and send for general purpose. And if you take a look at my program.cs, I'm configuring the HTTP client here. I named it API, and I am setting the base URL. Why I'm mentioning these details? Because we're going to see some magic stuff or really fantastic features that Aspire uh, gives us. As you can see, I'm setting the base URL from my app settings, which is localhost with port 5001, right? So I need to define exact port, exact address. And if I try to change something like the port or the address, I need to change everywhere that I am using, right? So keep in mind this one, because we'll get back to this. And the others are the usual rules. Right. So now I'm going to decide to add .NET Aspire to this existing project. For this, simply I can right click on the API project or the other one. I start from API project, and from the add menu, select the .NET Aspire Orchestrate support. When I click on this button or on this menu, a pop-up shows up, which this is telling that I'm going to add two more projects to your project, to your solution. And let me add this in another directory. Let's call it Aspire. And also to make it more beautiful, creating a solution directory or folder and put it in here. Okay, so as you can see, this project app host project is bold. And of course, you know that when this is bold, it means that my entry point or running project is this project. After adding the Aspire project to my project, I, I'm having two more projects. One is app host and another one is service default. App host project acts like an orchestrator. It means that if you have a database, if you have an API service, if you have a client, if you have a Redis for caching, if you have any other services, this project is responsible for uh, managing all other services. And if you take a look at the program.cs of AppHost project, that's truly simple. It's really simple. And you can see that by using add project extension method, I'm adding, or it added automatically to the project, my API project. And you might ask question how it recognize that I have a project called project underscore API. It doesn't matter. It's .NET behind the scenes. It recognize your applications, your projects that the app host is referencing to them. And currently, as you can see, I'm just referencing to the API project. And if I add more reference, like adding reference to the MVC client, uh, it will recognize it here. And let's see, just for check that currently it's not recognizing my MVC client. As you can see, here I just have project underscore API, the project that I reference to that one. Okay, so let's just comment this one and reference to MVC client. There are multiple ways. One is right-clicking on the MVC project and do the same process like this, add Aspire orchestrator support. Another one is drag and drop to the to the app host project, and another one is simply writing the reference here. It doesn't matter which way you are doing, but I'm using the menu that Visual Studio provides. And as you can see, it's added to my app host project. So let's get back to the program.cs project and uncomment this. And here you go. You can see that MVC client is added to projects list, right? So this is the definition of the projects that uh, we see here, and you can see that the uh, yeah, project pass, it's changed. Okay, no problem. So, and let me call this one client, and for simplicity, let me remove the project from the beginning of that. Okay, so I have two projects, one API and another one is the client application. Okay, so uh, I can do some more things. For example, uh, I want to not start the client application before starting the API, right? For example, I need to wait. I need to wait to run the API project. Simply, I can use wait for, and here I can give a name like API to this one, and let's call this client. By providing or using this extension method, I'm telling to my application or the .NET Aspire that, hey, wait and do not run the client application until the API application is run. And also I can do a reference to my web API project. And if I need to use another things like the databases, the containers, or anything else, simply I can use builder dot add, for example, container, which we will see next minutes how to use unsupported tools like, or for example, your client application is not a .NET application like Blazor or MVC. It's a React application. So what should I do at that case? In that case, you can turn your React application to a Docker image and simply use add container to run that one. So uh, the .NET Aspire is a new feature from Microsoft designed to simplify building cloud native distributed applications. So it's going to make us make the working with cloud uh, easy, right? So, and the good part or important part is that it sits top of the .NET. This is the .NET, and the .NET Aspire is going to sit on top of the .NET because it's going to wrap up all my application, my old application, and uh, and then I can use everything that I was using. I was using like the database, the API service, the Postgres, caching mechanism, or messaging system, or anything that I was using. Uh, and also, as I mentioned at the beginning, it provides some packages, some built-in packages like Postgres, like Redis, like EF Core, but still it needs to be create more packages because still we have some tools and technologies that are not supported by .NET Aspire, and we need to run them with containers. Okay, the .NET Aspire pillars are, the important parts of a .NET Aspire project is the orchestration. .NET Aspire, it manages multiple services, containers, and resources in the development environment. And not just development environment, it's personally in our company, we are using .NET Aspire in our production too. Another one is service integrations. It offers pre-built-in packages for connecting to database, to using cache system and cloud services. For example, if you are using Azure Monitor, you can simply, by writing 2 or 3 lines of code, you can connect to Azure Monitor service to monitoring your all services. Another one is observability. Uh, the .NET Aspire built-in supports for logging, tracing, and metrics to monitor your app's health by providing your health check URL and providing the logging system and monitoring system, and also it has some metrics. So uh, imagine we're working on a project with an API, a front end, and a database. Normally, we spend time configuring each pieces like connection strings, ports, health checks, and other stuffs. .NET Aspire automates this. Remember, I showed that I'm using this URL, right? I showed that I am using this connection string, right? But by using .Spire, all of these are going to be automated. I mean, are going to be configured, automated. So this is really nice. It's like having a development time assistant that sets up your environment and enforces best practices, because I'm not going to write code. It is implementing all codes, configurations, and other stuffs by itself. And of course, it's using the best practice. And it led me to focus on coding, not configuring Redis, not configuring RabbitMQ, configuring the Postgres and other tools that I'm using. For our API and MVC project that you can see, it can simplify service discovery. It means that if you pay attention, I didn't do anything. I just added my project or reference my project to AppHost. That's enough. And this is acting like a service discovery. I don't need to use any other package or other tools as a service discovery. By writing these lines of code, it's done. It's done. And of course, it enhance debugging and prepare us for cloud deployment, because if you remember, when I ran the project, I had 2 terminals which I could see the logs of my both applications separated in 2 terminals, right? But and imagine if you have, for example, 10 API services and 2 other services, one database, another one for Redis, another one for Postgres, and other stuffs, right? So how many terminals or logging output you should check for checking the logs. But in .NET Aspire, I'm going to have very simple or one place to see the logs of all services. So, uh, yeah, that's it. Okay, so uh, I talked about the app host, and let's see what is service default. Service default is shared configurations for logging and telemetry and the other stuff that is shared between all applications. As you can see, I have add service defaults here, which is configuring my services like the service discovery, like the health check, like the open telemetry and the others. Okay, so, and because I'm out of time, I'm going to make it faster. So, yes, this is for health check, and this one is for live and health URL, and for monitoring, if you're using uh, Azure Monitor, you can simply use this one. And okay, great. So just let me add one or two more things, and I will uh, finish my presentation. Okay. Uh, if you are using, we are not using .NET all the time. We might use other services like Redis, like React, like Postgres, like other services that are not uh, the .NET base tools. So what should I do? For those situations, we can use, as I mentioned, the dot add container and use the container, right? So, or if I'm going to use the Redis, which is supported, currently supported by uh, Microsoft, I can simply just add Aspire package. It's nothing but just it's filtering the Aspire packages, which you can see that I have the Redis, I have the Postgres, and the other stuffs. If you want to use this, it's really simple. You need just add the Postgres. Let me change the version because I'm using the version 9. And here we go, builder dot add Postgres. See, that's simple. And also I can add the database, for example, people. And of course, because I'm using SQL Server, I need to change some configurations in my API project. Instead of using SQL Server, I need to use Postgres, but I'm not going to go through into this because I'm out of time. And well, yeah, I think that's it. Oh, okay. So for the last part, let's run the application to see what happens when we use .NET Aspire, or we add .NET Aspire to the project, please. Okay, finally. Great. So this is the dashboard of the .NET Aspire. It doesn't matter how many services you have. You have 10 API services, you have two databases or more, you have three clients, one in React, one is Blazor, one is MVC. It doesn't matter. All of them are here. We list here, and there is a console tab here which you can see the logs of your services here, and the other ones like the structure, the uh, traces, the metrics, and I'm not going through these. You can uh, do a research about them, but just for make sure everything works fine, which is not going to work fine because I didn't change the address. Oh, it's working, but it's because it works with both of them. As I mentioned, in here, I don't need to specify the port and the address. I just need to use the name of my service. That's enough. That's enough, and it will find out that what is my service. This is the service discovery. This is the great feature that uh, .NET Aspire provides, and I'm going to rerun the project to make sure everything works fine.
I just hate to bug you, Kamran, because we're running out of.
Yes,
I know
sorry.
we will start a little late, but I'm just hate to bug you. I know you hate me already.
Yeah, of course.
So,
So
so
I'm
while that
done.
happens,
I'm
yeah,
done.
yeah,
I'm
you're
done.
done. Perfect, right? So I think that that was very nice. I know we're running out of time. I think we're only 4 minutes into the next session, but and there are quite a few questions in the chats, right? I think there are quite a few questions. So let's just take maybe one at least, right? So that people don't yell at both of us. It's coming from Oleg. He's saying, can Aspire replace an existing .NET apps plus Kubernetes plus Docker ecosystem? That's a very strong ecosystem to have. But can Aspire do it?
Uh, in my opinion, yes, of course it
Oh
can,
wow.
but not today. Not today, because as I mentioned in my presentation, it's really young feature. Let's say young feature because the Kubernetes, the Docker, they're working many years, of course, and as I showed up in the Aspire NuGet packages. We had maybe 20 packages
Yeah.
yet, but in the future it will grow up, and of course it can take the place of Kubernetes and Docker.
Perfect. Thanks for that answer. I know a strong belief that Aspire can take it, yeah, but not now, but maybe in the upcoming future. Thank you so much, Kamran. I know it's getting evening at your place, right? Thank you so much for sharing your pearls of wisdom with this community. Thanks for everything that you do for the community, and I can't wait to host you back once again. And yeah, thank you, and have a nice evening.
Thank you so much for letting me to be a speaker in this live. Thank you so
Yeah,
much.
thank you so much, Kamran. All right, ladies and gentlemen, we now need to get a rush. We got to sprint to the next session because our next speaker is waiting behind the scene very, very patiently. She is Purnima Nair. I've been following her for so many years, Wonder why am I hosting her after all this time? She's super active in the community. She's a Microsoft MVP. She's an Umbrella MVP. She's a .NET developer, .NET Foundation Outreach Team committee member. And today in the .NET conference, she's going to talk about transforming synchronous web apps with asynchronous messaging. So, without any further ado, let's bring Purnima in. Hi, Purnima. How are you doing today?
Hey, Stephen. Great to meet you. Yes, we have been following each other for a while, I guess, but you know. Some things has to wait. So it's my pleasure and privilege to be here. And thank you, C Sharp TV and .NET Conference for having me on this conference. It's great to be a part of such a privileged speaker lineup.
Wow, thank you so much. I love your energy already. You're an the moment I saw the Umbrico MVP, I was like, whoa, I know Hank, right? So me and Hank, we,
Yes.
we often hang out sometime in Europe, sometime in India. So I was very excited to see it. In fact, I was gonna be there at Azure Lowlands, but visas are always an
You
issue.
missed out. You missed out, my friend. That's all what I can say. Hank's conferences are just amazing.
Yeah,
So if the next version of Azure Lowlands come around, have a look at the lineup, and
yeah.
the conference is pretty fun. That's all what I
Yeah,
can say.
yeah. No, at this instance, he's doing the agent con somewhere, right? Utrecht or somewhere, right? All right, no more
Yes.
chit chats. We'll do later on. Purnima, please feel
Yes.
free to go ahead and share your screen, and then I'll get you added, and then you can start the
Okay.
session.
Share my screen. So let me see which screen. Screen number 2. Okay. I hope I'm sharing the correct screen. So if I change this, do you see Rider? Yes. So I am
Yeah,
sharing the correct screen.
yeah,
Brilliant.
perfect. All right, Purnima, next 35 minutes is all yours.
Okay, I'll try to stick to the next 35 minutes as much as I can, because in my last practice run, I went up to 37. So let's see. So thank you again for having me here, to the entire conference organizers. And today I'll be speaking about synchronous web apps and how we can approach web apps from a messaging architecture point of view. As developers, one of our greatest and perfect dreams is to get our hands dirty with code. What I mean by saying is that as developers, nothing excites us than getting to work on a project with tons of integration patterns, right? Creating databases, entities, defining workflows, and if you have a ton of external APIs, you know what? Let us just get through it. You can't just wait to work on such a project. Sounds perfect, right? And I think that's a very relatable situation for all of us who are developers. And it's a dream come true as well. So we work on such projects and then we put our projects live. Fantastic. It's a moment of pride and joy when your project hits production and starts making money for the business. And there's no other joy like showcasing your own work. Again, something relatable. And then comes that first campaign that goes out as a mass email to how many people? Just about a few 100,000 people that the business has gained as the customer base. And then starts your rainy day. How? Because you notice sluggish front ends, or you get phone calls saying you have sluggish front ends. You notice that the backend services are not scaling quite well, or they are struggling to put up with the load. You might be taking payments on the site and that doesn't seem to work, or your payment processing gateway is hitting rate limiting territories. And at some point, you know what, the site just gives up, saying that, oh, I can't deal with this. I cannot deal with the spikes. Just do whatever you can. Now, this is something that we all have been there, done in the past. I have been there, done that myself. But there are other ways to face this reality more confidently upfront. And messaging is one such technology. And sorry, my slides are frozen. Why? What happened there? Okay, no. I am Purnima Nair. I'm a software engineer and solutions architect at Particular Software, where we build N-Service Bus and the entire service platform around N-Service Bus. I'm speaking to you from Berkshire in United Kingdom, and if you have any questions, reach out to me, DM me at Purnima Nair. I am as Purnima Nair on LinkedIn, X, and Blue Sky. So any questions, feel free to DM me, and I'll try to answer you with as many answers, the best answers that I can. So in the next 35 minutes, we'll pick up some basics on asynchronous messaging and how we can use messaging as an architecture to have really high throughput, high performant, mission critical systems. And we'll see some code as well. When it comes to mission critical or high performance system, the first thing I like to talk about is the order processing system. Why? Because it's a very relatable workflow for everyone. It is the holy grail when it comes to building distributed systems and talking about distributed systems. And what is a typical workflow? We go to the website, put a few products into the basket, click checkout, put our details in, then fill in the credit card details, and then say place order. Boom, and that order goes into the backend system of the online shop, and then it gets processed. That's the happy day. That's not the rainy day. That's the sunny day that you can see, just like the day I have out here in UK. That's a perfect case scenario. Now go back and rewind to that campaign scenario. Where were you at that point when you had that rainy day? So we had a sluggish day. We started off with sluggish front ends. Sales are reported to be very low. Fine. You know what? We are on Azure. Let's just scale the front end. Auto scaling is what? 10 minutes max? Fine. We do that. Have we solved the problem? Not yet, because our backend services are struggling to cope up. It's still slow. Fine, we are going to auto scale our backend services. Now, there's a catch there. Legacy backends. Who has dealt with a backend system or API server hosted in an old server somewhere in the basement of a building? Been there, done that. There's an API which just couldn't be scaled. That's a catch in itself. Let's just not talk about it. But let us say that we have started scaling our backend services as well. And then at one point, we hit the wall, the database. So we have been moving the bottleneck from the front end to the backend services to the database, where it just goes boom. You know what? I cannot cope up with the amount of traffic that is hitting me, says the database. There's so much resources that you can throw at it, but what really happens is cascading failures. The database fails, it then goes and fails the backend services that we have scaled out, and that goes and fails the sluggish front end, which is also being scaled out horizontally, vertically, all way, but it then just blows up on the face of the user. We are not making money as a business, and that is the rainy day that I've been talking about. Yeah, so I've been there, done that myself. Years ago, I was working on a system, and when the mass email campaign went out to their very loyal customer base, we had like tons of people hitting the website, and we had a legacy API. And there was a point where I live monitored a system with my colleague over a phone call with a customer, and that went on for a couple of rounds. And that is where we start thinking about, did I use the right tool for the project? You know, could I have done this better? So what did I miss out? Did I miss a memo? And the memo that I missed out happens to be the fallacies of distributed computing. So what we have been speaking about so far is a distributed system where two or more computers speak to each other. So as developers, when we develop distributed systems, we take many, many things for granted. And those false assumptions have been coined together as the fallacies of distributed computing, the things which we fail to see upfront. This is a list of fallacies that was put together originally by Peter Deutsch. I will be leaving a link to all of this in my resources at the end, so keep on watching. But let us talk about these fallacies for a minute. We assume that the network is reliable. We assume that network will always be up and everything that we send will be received. But in reality, network can fail, information can get lost, and network could become congested, right? We assume that latency is zero. We assume that requests will complete instantly. But in reality, there is always a delay, millisecond, microseconds to even more in some cases. We assume that the bandwidth is infinite, but bandwidth is finite. There's a limit to the bandwidth. You can have slowdowns and bottlenecks. We just cannot send as much data as we want at any point. We assume that the network is always secure. We assume that, now my network is secure, there's no one coming to attack it. But we need to understand that in flight request, there's always a chance that someone could intercept it. We assume that topology doesn't change. We assume that servers, nodes, routes, they all are static and constant and they don't change. But in reality, machines crash, they restart, they get migrated, they scale up and down. So we cannot assume that there is no change. In fact, change is constant, and as developers, we need to embrace it. We assume that there's just a single administrator. But in reality, there is nothing called a centralized control these days. It's more about distributed teams. You could have multiple teams working on the same distributed system. And when that happens, if you don't have enough inter-team communication, inconsistencies and failures happen. But is there something called as enough inter-team communication? I don't think so. We assume that the transport cost is zero. Even if we have infinite bandwidth, the transport cost is not zero. There is a little bit of that extra that you pay at the end of every month with your Azure bill that comes around. That is what telling you is that transport cost is not zero. There is always cost associated, even with CPU performance and usage. And we assume that network is homogeneous. But is the network homogeneous? Is the behavior always uniform? Never, because no two systems or no two servers are alike. Let us go back to our order processing workflow and see what might the workflow be. So we have our website, which is pushing the orders, or when you hit that place order button, goes into a big service called the order processing service. The order processing service then might reach out to the sales service and say, hey, create this order for me. And the sales comes back with a response. Then the order processing goes and talks to the order payments. Sorry, the payments is hidden here. The payments and says, hey, build this for me. And then somehow it gives a response magically. And then it goes and talks to the customer status service to update the loyalty points. And then it might then give the response back to the order processing. And then the response goes back all the way back to the client. That is when the client gets to know, yeah, the order has gone through. Now, what you might have, compare this with the policies that we just spoke about. What if one of the services is down? What if the network is congested and the data doesn't reach on time? There could be the chance of HTTP timeout exception, right? What if one of these services has been updated by a team and the other services just cannot cope up? There is the risk of that too. So what we have is a scenario of very tight coupling. Each service, like if you look at the order processing service, it needs to know that it needs to call the sales, it needs to call the order, it needs to call the order payment, and it needs to call the customer status. Why? Why can't just the order processing hand off and then just move on to do other things? That is what you want to do, right? Here, there's too many responsibilities on any service that is doing it. And you might think at this point that you can bring in Poly to keep doing the retries if there's failures happening, but that's not enough, because what about the data and the idempotency around it? Do you want to take the payment twice? No. The underlying problem here is what's known as temporal coupling. This is the tight coupling that I've been talking about. The idea that for two services to communicate to each other, they should be up and running at the same time. So if there's a sales service and the order processing both needs to be up and running, I need to get the response back after talking to B directly, and only then can I move on. So if B crashes, there is no request, there is no response, right? And at that point, A is completely blocked, A cannot do anything, and there's failure on the face of the user. And while that request has been sent to B, A is still waiting, doing nothing. Yeah, that is money lost probably during that time in compute power. There's also the request response pattern that we see here. I am not saying that this is a problem, but when it comes to high throughput, high performant scenarios, we cannot rely on request response because it follows the synchronous processing technique. Because HTTP by nature is synchronous, we cannot have async processing with request response. So this is also that something cannot really fit into this high throughput, high performance scenario, mission critical systems. So what we have built here is a house of cards, and not just a house of cards, but one that is sitting on top of Asian waves. Now, this is not about bashing HTTP APIs or gRPC, GraphQL, whatever, because they are all battle tested. They are there for a purpose. What I'm talking about is mission critical, high throughput, high performance systems where time is money, where you cannot have failures, and probably there an HTTP based API is not something that you should be using. And how can we change this? How can we have better foundations? By introducing what is known as a message queue. So in reality, it is Not as simple as this. There's a lot of thinking about the problem and the solution before you go into implementing this. But to have an introduction to messaging today, let us just assume that we have introduced a message queue in between. What is a message queue? Consider it like a database, but instead of rows, you have little messages. And what are messages? They are basically what you would have in your request, information. So with the message queue in place, A will actually send a message into the message queue. And at that point, the message gets stored into the message queue. A is not blocked at all. A can continue doing whatever else it needs to do. And B is on the other side of the message queue. B might be crashed at that point. B might be undergoing an update, or B might be online. But whenever B is ready to process things further, it takes the message from the message queue, processes it, and deletes it. So in a single shot, we have gotten rid of the temporal coupling, and note that there is no request response. Why? Because message queues or message brokers, they rely on protocols like AMQP, which by nature is asynchronous processing. So where do we start with this? I'm going to be focusing on the technical aspects of it. But if you want to head over to particular.net/blog, which I'll be sharing a link today, there's a lot of information about what goes into actually planning such a project. How can we migrate, or how can we even start greenfield projects? But today, in this 35 minutes, I just want to focus on the technical aspects of it. So the main thing to talk about, or the first main thing to talk about, is the message queue. There are a variety of options out there. It can be queues or brokers. Brokers are much more advanced in terms of functionality with routing and message filtering, message transformation. A talk for another day, but understand that there is message brokers and queues. So there's RabbitMQ, the open source. If you want something in the cloud, which is a more queue version, you have Amazon SQS. Then you have Azure Service Bus, which is in Azure cloud. And then you have ActiveMQ, ZeroMQ, IBMMQ to Google PubSub. Now, all this are infrastructure. This is extra infrastructure being brought into place. And then you also might be moving in from an HTTP to a messaging environment. So you might want to play around, have a look, gain some confidence about messaging in general. In such instances, we have seen database as queues, using SQL Server as queues. Why? Because such organizations who doesn't have enough confidence with messaging from the word go, they find it easier to have SQL Server, which they might be already using in the application, and use that as a queue. It's okay in that kind of a scenario to use it, but when you think about real high throughput scenarios, using database as a queue is probably not a good idea, because it's also adding load to your own database service. Now, we have our messaging queue in place. Suppose, say, for today, I'm using database as the queue because that is the easiest to set up. But say, if you are using RabbitMQ or SQS or Service Bus or even database as the queue, how would you go about talking to it? Would you use the native client library? Not really, because there are so many things that you need to ask yourself when you go down this path. What patterns do you need to support? Is it send and receive and publish subscribe? Which one do you need? Because with publish subscribe, you're going down the event-driven architecture route. What is your average message size? Do you need large message support? What about the complex routing that you might need in place? Do you want to write things yourself? No. How about the message delivery order and the delivery guarantees? Are you after at least once, at most once, or exactly once processing? What about data transactionality and the idempotency of data? Surely you don't want to take payment twice. What about the throughput? Do you want managed service or self-hosted service? Are you after cloud-native solutions? To what local dev support you need? All these are things that you need to ask yourself. And on top of that, you need to be also thinking about a variety of patterns that I'm just going to talk to you about. Message routing, workflow, transactions, claim check pattern, serialization, retries, monitoring and alerting, because it's a distributed system. All in all, you might end up writing all these patterns that you see on the screen. So would you want to do that yourself, or would you want to do it a different way? That is where messaging middlewares or messaging libraries come into play. There are many options which I'll be talking about, but I'm going to use the analogy of a car here. Suppose you want to have a new car with all the latest features out there? Would you go buy a car for yourself and use the amenities that it provides you with? Or decide, this sounds fun. Let me actually build a car. Trust me, there are people who build a car, but then you have to think about the roadworthiness of it. You have to consider the paperwork that goes behind it. Do you really want to be doing it? Of course, there is the learning, but then one of the key learnings at the end of it would be, I don't want to do it ever again. I don't want to be servicing this car. It is going to sit as a car which is not going to be used on my driveway. I built that car, that is it. I don't want to be servicing it. So my point being, do not reinvent the wheel. Use one of these libraries. And Service Bus, Mass Transit, Writer, Rebus, Wolverine, all of these are messaging libraries. They all come with patterns that I just spoke about that has been built in. You can make use of those amenities yourself. So this helps you focus on the business code. In today's example, I'm going to be using N-Service Bus because that is what I am used to. But regardless of that, feel free to use any of this, because all the code that I show you, it is just the APIs that keep changing. The patterns are the same regardless of the library you use. So just putting it out there, do not reinvent the wheel, because what you might end up writing is a cheaper version of one of these libraries that is going to cost you a fortune in the long run, servicing and maintaining it. Save yourself from the headache, because a distributed system is no mean feat. So time for some code now. So what we will discuss are these main points: endpoints, commands and point-to-point communication, events, publish and subscribe. We will see if we can extend our system if time permits, and we'll also talk about recoverabilities and retries. So let's go to Rider. What I have here is a solution with 4 projects. I have unloaded something. Let us bring that into picture when the time is ready. So the client UI is basically the website, which is the web front end, ASP.NET Core MVC application, nothing too fancy about it. And I've got 2 services, which is the sales endpoint and the billing endpoint. So in reality, I might be hosting these as Windows services, the billing and the sales endpoints as Windows services, or even as like an Azure web job. The client UI, that is a website that could be hosted anywhere or even on Azure. So as I said, I'm using N-Service Bus because that is what I am familiar with, but feel free to use Mass Transit or Wolverine or Rebus, because the patterns just keep repeating. It's just the semantics and the APIs, the names of the APIs and the methods that keep changing. So in my controllers, I have the home controller. There's a place order button. So if I just run this demo and show you what the web front end looks like, it is very simple and basic for this 35-minute session again. So I have this big button which places an order, and it tells me that an order has been placed. So when that place order button is clicked, what happens is it goes and invokes this action method for me. So in here, I create a new order ID, and then I instantiate something of the type place order, and I am sending that object that I've just created using something called message session. So what is actually happening? So message session is like an interface in N-Service Bus that helps me do basic operations on the message, like sending a message or publishing or receiving a message. And I am using that to send something. Now, what is that something that I'm sending? So if we look at the place order class, it's a plain old CLR object, which inherits from I command. And this is what I'm sending. In reality, it will be your entire request, which contains all the details of the products and everything. That's one way of doing it. But inheriting from I command is telling the system, that is, it's telling an N-Service Bus that, hey, this is a message. This needs to be treated like a command. Now, in comes the concept of the 2 different types of message here. This is a command. A command is an instruction. So it is a very valuable method. And me as a sender, I expect someone to take action upon it. So if I expect someone to take action upon it and it is a high value thing, I need to make sure that I know at least who is going to deal with it. So that also can be configured. But as a sender, I don't need to know whether that receiving party or whoever is going to deal with my instruction is up and running or down or whatever. I just need to know that there is this someone who I need to send the instruction to, who is going to do the work for me at some point. So using the message session, I'm sending that command, and how that sending is controlled in a centralized manner is from the program.cs. So here I have this API called route to endpoint, where I say the type of place order classes or the objects of type place order, the destination would be the sales for it, the sales endpoint or the sales queue. So as you can see, there is a website and it is talking directly just to the queue, not the sales service. It's the sales queue that it is talking to. So it centralizes all the connection for me. And this is now also an endpoint because that is how we treat things in service bus. An endpoint means it's a service that can send or receive messages. And of course, there is the configuration for the SQL transport, which I'm using today, and a little bit of service bus endpoint configuration. So that is the client UI, which sends the message or sends the command. Now, let us go and visit the sales service. So the sales service is where the place order instruction is received. So it needs to process that command. And for that, there is a class which says that, hey, I am here to catch all the commands that you send of the type place order. Let me deal with it. So in the place order handler, we have a class that inherits from iHandle messages of type T. So marking a class inheriting from iHandle messages of the type place order say is shouting out loud to the system that I am here to handle all the commands or all the messages of the type place order. And inside my handler, there's a handle method where I can get the message as well as the context. So if you think about HTTP context, the iMessage handler context is something like that. It gives me access to the context because this is a service that has been invoked by a message. With HTTP APIs, you're invoking using HTTP request. Here, it is invoked using a message. So in here, I can then do some business logic that is processing the order or saving it to the database in this instance. And then we have some interesting things happening. If you see here, there is another object called order placed being instantiated. And I'm using the context API, the publish API in the context to publish it. Here, I'm not sending, I am publishing it. So what is the difference? So this is an event. Event is like letting the world know that something has happened. While command is an instruction that says, do this, event is like something happened. I have done it. So the sales endpoint or the sales service is saying that, yeah, I have saved the order to the database. My job is done. I am just letting others know that I have done my job so that others can pick up on what is left to do. So as you can see here, there's just one responsibility residing on the sales service, which is creating that order in the database. So another thing to note here is that the order placed event is again very lightweight. In reality, it might be different, but the order placed inherits from iEvent, which lets the system know that this is an event. Now, if you look at the semantics of a command and event, the event semantic is a noun plus a verb in past tense. And for command is like a verb in present tense plus a noun. So that this way you can easily make out which is a command, which is an event without even going to the without even going inside the class and peeking into the class. So something like a best practice. So now we have published the event. And if you look at program.cs, I'm not talking to anyone, right? Because that is because this is an event. I just need to let the world know whether someone will listen to me, how many listeners will be there. I don't care. I just need to let the world know. It is like me talking to you. It's like a broadcast. There could be one or many listeners, and those listeners are called subscribers. And this is the basic of event-driven architecture. What we are doing as a pattern is publish, subscribe, and this is the basics of the event-driven architecture. And the beauty with event-driven architecture is that we get the space to extend the system easily because we can bring in more subscribers without affecting the system as a whole. Now, how do we handle this order placed event? That is getting done in the billing endpoint or the billing service. Here we have a handler, again, which inherits from iHandle messages of type T, which is order placed. In the handle method, I can again do some business logic. And then at the end, I might send another command or publish another event. That is also possible. Now let us see the demo in action.
Yeah, that's what there's one of the new box, the one that is in RM4.
So let me bring up the
Yeah,
point
yeah.
4, the run window. So I have the client UI here. I'm going to place a few orders. Just let us start with one to begin with. That is CFB4 is the starting. If I look at the sales, it has received the place order instruction. So if I look at the client UI to begin with, I'm sending the command for the order ID CFB4. The sales receives it and then publishes the event for the order ID. And in the billing, I have now received the order placed and I can move on and do other things. Now, we spoke about extending the system, right? So I have another service that I have just hidden here. I'm going to load the project and then I am going to run this as well. So right now it is not running at all. I'm just going to run this. Again, this is a very simple handler which handles the order placed. And if I run this now, that should also run. Give me a minute. I think this is up and running now. If I go and place a few other orders, I should see that the shipping or endpoint should receive some of the messages as well from the past. So we have extended our system without impacting the system as a whole. Now, what if one of the endpoints is down? It has a bug. What happens behind the scenes? That is when the recoverability and the retries come in. So let us go and introduce a bug into our sales endpoint by just throwing an exception. So let me just stop this and then rerun it all.
Like you said, obviously, it has
so the sales endpoint is completely failing at the moment because I have introduced a bug, but that doesn't prevent the UI from working. I have placed a few orders now, and the client UI must have sent a few messages. But when it comes to sales, it keeps on failing. So now what happens is, in the sales, I've got some recoverability in place. This is something that you would add to every endpoint. And with the recoverability, it says that, hey, when you have an error, retry it. And when the first retry fails, then back off exponentially. 2 seconds, 4 seconds, and so on, till the point you cannot do it anymore. And then what you do is you don't sit and do anything. You move that message into another queue called as the error queue. And that is what is going on here. I think it retries for like 3 times before it completely backs off and moves the message into the queue. So if you look here, there should be some messages in the monitoring area, which I'm just going to show to you right now.
Yeah.
Let me bring that up here. I should see a few failed messages. So if you look here, there is a message that has failed with the message body BF5CE, and that is indeed one of the messages that was sent by our client UI here. So at this point, sales is failing, but the client UI is up and running. So now let us simulate the scenario where we have gone and fixed the bug. Yeah. So here we are in the placeholder handler again. We have fixed the bug and we are running the app again. And now what I can do is when things are up and running, I can go back to the monitoring area and then start retrying my messages, the failed messages. So I can go into here.
There's definitely not in the console.
Here in Service Pulse, and I can see failed messages. I can go into one and I say retry this message. Yes, I want to retry this message, so it is getting retried. Now if I go into sales, I should see that it is going to try and pick up the message that just failed. So let us see. Come on.
Because we don't.
It is retrying.
I can send you. I can export this wherever they are, but I mean, we don't get tickets for these. I mean, security is not bothered.
There you go. So the message with the message body BF5CE, that has been retried, and the order placed event has been published, and then the billing can receive it and the shipping can receive it. So the idea is that you can extend the system, and even if there are failures, the request is safely and durably stored somewhere, be it the error queue, so that you can bring things back up and retry it. So you're not losing any message. You are building that defense in place so that nothing is lost. Similarly, we can select all and retry, and it should all go through without overwhelming the system, or it should at least get processed one by one. So we should see that in action any minute. So I'm just going to move on, and we can come back to it and visit the logs later. So we discussed all of this: endpoints, commands, and point-to-point communication, events in publish and subscribe. We saw about how you can extend your system without impacting the rest of the system. We saw about recoverability and retries. So we have moved on from that very monolithic architecture to something like this. So you have the client UI, which it sends a command saying place order to the sales endpoint. The sales endpoint then publishes an event called order placed, which is consumed by both billing and shipping. And here it gets interesting, because the billing can then produce further events to say, I have billed the order, at which point the shipping can chip in and say, you have placed the order is confirmed, you have billed the order. I might also want to wait for the stock service to come back and tell me that there is enough stock so that I can start the shipping. So that is a very complicated thing happening behind the scenes, and that is yet another integration pattern called the Saga pattern, which you might want to investigate, and that is used for having or creating workflows. Further, the billing might publish the same order build event that the billing published. It might be used by the email service to pick up the fact that a confirmation email needs to go out to the customer. And finally, the order build that could be picked up by the customer loyalty service to say that, yeah, I have updated the customer loyalty database or the details of the customer as well. So all in all, if you see, you are moving closer to your business domain with such a kind of architecture at play. Now, talking about where you would see such message-driven architectures at place, when you have communication between services, when you want modules in modular monoliths communicating with each other, you can investigate into message-driven architecture. In real life, you would see such architectures at play in industrial automation, healthcare systems, banking and finance. Anywhere you want to have high throughput, high performance scenarios, mission critical systems, messaging architecture can vitally help there. And if you are thinking about messaging architecture, these are some scenarios where you shouldn't be using them. CRUD applications, when you need request response, or even real-time application. Now, revisiting the fallacies of distributed computing, what is the verdict? How does messaging fare? So network is reliable. We embrace failure by design by introducing durable storage, retries, and DLQs. With the latency, we have introduced async processing, and we have decoupled time. There's nothing called the instant processing. It is all eventually consistent data. We are tackling bandwidth by achieving some load leveling, because backend systems could process at a normal rate while the client UI alone is scaled. So there's load leveling happening. The network is secure because all the message brokers, they take care of TLS encryption of in-flight services. And with fine-grained services, the attack surface is also reduced. With the topology that doesn't change, we saw that we can evolve with minimal disruption. We can take entire consumers down for maintaining and servicing, and that doesn't impact the entire system at all. We can have different teams working on different parts of the distributed system, and they all can work independently and have team autonomy. We can scale just the necessary services and deal with the spikes. For example, you could just scale the client UI alone to have multiple instances for the user-facing fend, and then the backend services could be just one instant and keep processing data at a normal pace, achieving load leveling. And we have an inherently polyglot-friendly architecture in place because the underlying protocols like AMQP and MQTT, they are language agnostic. and enables communication across different platforms. It doesn't solve all the problems. What messaging helps you is confront the policies early on, and these policies, as they are, you are forced to ask yourself those questions early on to mitigate the risks. So that is it from me today. That is the QR code to my resources and my resource link as well. And if you want to reach out to me, feel free to reach out to me at Purnima Nair. Thank you. And thank you once again for having me as a speaker.
Wow, you really need to get a glass of water, Punima, because you've been speaking non-stop, right, from last 35 40 minutes, right? Especially I was looking at the demo, right? It was so smooth and very so this is very nice, to be behind the scenes and look at your demo. I
Oh,
just
thank
really
you
liked
very
it.
much.
It's been a while I've seen such a fast-paced demo, and yet it was so good. There were
Thank
no
you
demo
very much.
demons. I think even if there was a demo demon, I didn't really realize it. But it was very good. I know we have Alvin waiting behind the scenes, and we have quite a few questions. Yes, maybe let's take at
Yeah,
least one. Right, let's take one
sure.
maybe. Let's say take Hemant this time. He's asking, how do you ensure message reliability and avoid issues like message loss or duplication, especially during high traffic?
Okay, these are two very different things. Message loss, rely on a messaging library. Please let the messaging library take care of you, because that's not something that you can handle yourself. There is message queues, but you need to make sure that you need to focus on your business code. So use a message library that will take care of the message loss for you. Now, when it comes to duplication, that is yet another pattern that you can invest in, which is the outbox pattern. So that takes care of exactly one's processing and make sure that there's deduplication and idempotency of your data. It's not something that I can explain in 5 minutes because it is really, really, really advanced as a topic, something which needs 1 hour. But I have something for the audience who asked me about it. It is a podcast that I'm going to direct you to. There's a 1 hour podcast about the outbox pattern. So that is what I am talking about. So, Stephen, I'm going to put this in the chat here. Maybe you
Perfect.
can then put it in the live chat. So this is a link to a podcast. It is a 1 hour podcast by my colleagues, Tomek and Shimon, who did it with my friend Dan Clark. 1 hour about outbox. It'll teach you all about duplication, deduplication, and idempotency.
Perfect, Purnima. Thank you so much. I really enjoyed hosting you, and I can't wait, to have you on these events once again. Maybe I'll come to your part of the world, right? And then we can.
Welcome.
Or maybe whenever you're coming here. So with that said, Punima, thank you so much. Right, it's what evening at your time, 6 or something. Right,
No, it's 5 o'clock.
it's fine. All right, all right. Have a nice evening, Punima. Thank you so much once again, and yeah, enjoy your evening.
Thank you very much.
Yeah, thank you
Bye.
so much. Bye. All right, ladies and gentlemen, that was Purnima for you. And our next speaker and the final speaker for this conference has been waiting. It's been very kind already, right here. And he's been waiting for at least 10 minutes behind the scenes. So thank you so much, Elvin. Elvin is our next speaker, and he's going to talk about build native Windows app with WinUI, .NET, and Windows App SDK. And if I'm not wrong, Elvin, where did that go? Alvin is a senior content developer at Microsoft Learn. Who I finally get to host someone from Microsoft Learn. So without any further ado, I want to have some chit chat with him. So without any further ado, let's bring Alvin. Hi, Alvin. Welcome to the .NET conference.
Hi, how you doing, Simon?
I'm doing great. I just read you're a senior content developer at Microsoft Learn. How long you have been working with Microsoft Learn actually?
I've been there a little over 3 years now. Before that, I spent about 25 years doing software development and architecture, mostly with .NET.
Oh, I see. Because I remember, right, Microsoft Learn was introduced around like pandemic or something, right? And before that, we have a Microsoft Virtual Academy, right?
Right.
MVA. Yeah, so I've hosted quite a few folks from there, from that time. So it's so good to see you, Alvin. I know I'm only 10, 11 minutes in your session, so I've added your presentation to the stream. Everybody else can see it, and you have all the time that you need.
Okay. That sounds great. So we have about 40 minutes. Sounds good. Let me get right started here. So this is getting started with WinUI and the Windows App SDK, and also with .NET, because this is all using .NET if you're doing C# projects. So a little bit about me. I've been in the industry for almost 30 years now. I have a blog, The Morning Dew. It's at alvinashcraft.com. A lot of you may be familiar with that. I post links to .NET resources for developers every day. I've also written 3 books for Pact Publishing. 2 of them are 2 editions of Learn WinUI 3, and then I have another one that's on parallel programming and concurrency with .NET. And like I said, I've been at Microsoft since 2022, just over 3 years now. Content developer working on the Windows developer docs on Microsoft Learn. And I'm an organizer too of a developer conference. The Tech Bash conference happens every fall in the Poconos, in the Pocono Mountains in Pennsylvania. So that's Tech Bash. We're in November this year. If you're in the area, you should join us. We're going to have a lot of great speakers. We'll be announcing some keynotes very soon. And the agenda. So I've got a couple of things struck through here. I normally do about a 60 to 75-minute version of this talk. So I've cut out a few things for this version of the talk, but all of the slides for everything and all of the code samples are all up in my GitHub repo. It's just alvinashcraft/speaking. So you can go up to GitHub and get the resources for all of these demos. So let's start with a quick overview of WinUI, and then we'll get into some code quickly here. So WinUI is part of the Windows App SDK. The first release was in March of 2021. That was 1.0. WinUI 3, they call it WinUI 3, but it's not really a version number. It's kind of the successor to WinUI 2, which was an add-on to UWP to add some additional controls and libraries. And WinUI 3 is completely its own thing with the Windows App SDK. It's very similar to UWP. If you've done UWP apps on Windows 10, what they did was they took those controls and libraries and extracted them from the Windows SDK so that they could version these components independent of Windows. They used to be stuck with waiting for a new Windows release before you could get new UWP features, and now it's all separated out. The main difference between UWP and WinUI as far as looking at the code is the namespaces are changed. So everything starts with Microsoft dot instead of Windows dot in the namespaces. It's built on the latest .NET runtime. Right now you can build WinUI apps with .NET 9 or .NET 8. Both are still supported. You create apps with XAML and either C# or C++. And if you use C#, you're also using .NET, and you have access to the full .NET libraries, runtime, everything. And the latest release of Windows App SDK is 1.7. That just came out about 3 weeks ago. And it's open source on GitHub, not full open source. You can't contribute code yourself, but they do publish read-only versions of the code so that it helps with debugging. You can get access to all the source. And let's see, we're going to dive into the first demo here. So there's going to be 2 parts to this demo. So I'm going to create a new WinUI project from scratch and then show you how you can add a couple of things to make it look a little bit nicer. And then I will open up another project that's got an MVVM implementation, model view view model. And it's also got some controls and some styles added. So you can see the difference between the basic out of the box and what you can do pretty easily, just adding a few styles and controls to your app. So let's start with a new project dialog. We'll create a new project in Visual Studio. And we're going to pick a blank app packaged WinUI 3, and this is C#. And we'll just leave the name app 3 for now and hit create. So this loads up a couple of files here in your project. Let's see. So if we zoom in a little bit there, you can see this better. So we've got an app manifest. We've got an app.xaml, which is the part of the program that launches your app. So it goes into the app class first and then launches the main window from there. And the main window is exactly at the main window. Let's take a look in the app.xaml just for a second to see how that's created. So in the onLaunch method, it just creates a new instance of the main window and activates it. And then in the main window, the new project just gives you a blank window with a single stack panel. Stack panel just does exactly that. Anything you put inside there, it'll just stack the controls either horizontally or vertically, depending how you set that up. So this one is horizontal, so it would stack things left to right. And then in the code behind, each XAML file has a C# code behind file where you can put code. So here, there's just a button click event handler. So when you click the button that's in this UI file, it'll call that event handler. Let's just run this. I'm going to change this to ARM64. I have an ARM laptop here. Run it with no changes and see how it looks. It's building and deploying. And it's pretty basic. It's a big empty window except for the one click me button there. And you can see it's got a title bar with no icon yet. If I click that, it just changes it to clicked. And now I want to show you a couple of quick things you can do to make your window look a little bit nicer. I have this other app here. And this is exactly the same code, except I've added a few extra things. So the first thing I've added is this mica backdrop. And what that does is it gives it a little bit more of that Windows 11 look and feel. I'm going to take that and just paste it in our new project and run this again so you can see the difference that one little attribute makes there. And you can see it kind of has that pinkish hue now. So it's almost like it's picking up the color of your wallpaper in the background. So I've got a purplish hazy background and it's pulling that into the window here. Let's stop this and go grab the other piece that I have here. So the rest of this, so instead of just the stack panel, I have a grid wrapping it, and I have two rows in the grid. The first one has a custom title bar, and this is a new thing in Windows App SDK 1.7. It's a title bar that looks a little bit more like what you see in other Windows apps. You can add more things into the title bar, like you'll see in this WinUI 3 gallery app. You know, it looks like a little bit bigger. It's got a nice icon here. It's got a back button in here, and you'll see some apps like the store. They even have like a search box up in your title bar. You can do all that with this new title bar control. Let's go back to this app, copy this, and put it in here. So we've added this new title bar. I'll call this sample app. We'll put that in the title bar. I'm hiding the back button, and I'm not making it a tab stop because we don't have any controls up there that we want the user to be able to tab into. And I have to get one other piece to make that work. In the code behind, there's a set title bar method that we're going to copy and call that from the constructor. So let's paste that in here. And call it. And so here you'll see I'm setting the icon. I'm telling it to make it the taller height and setting the display name here as well. Let's run this again. And if we did everything right, we should have this nice tall title bar, but we don't have the icon yet because I forgot that step. Let's get our icon in here, add it to the assets folder. We're going to add an existing item. I'm going to browse out to this other place where I have an icon. And it's a WinUI icon. Now we've got that. Ooh, I got to do one more thing. We'll stop that. We have to go and set the properties on this so that we set it as content. Instead of build action none, we're going to say build action content so that we can reference it in the code. Now we should have an icon when this launches. There it is. We've got the larger title bar, looks a little bit nicer, and we got the icon set there. And it still works just like expected. When you hit the button, it says clicked. So that's a basic app. I'm going to pull up something with a little bit more to it now. These are all the samples that are out of my GitHub repo. We're going to start with this controls and MVVM solution. And in here you can see I've got a lot more going on. So we still have a main window and an app.xaml, but we also have some other views and view models. So in the main window now, you'll see there's nothing in there. It's just a window with the mica backdrop. So in here, instead of having the everything in the main window, we're loading each of these other views as a page inside the window. So all of my markup for what we're going to be launching is here in the main page. And this main page will get loaded, I believe, in the app.xaml. Let's take a look here. So on launched, we're creating the main window and we're adding a frame to the window. And then we're telling it to navigate to the main page within that frame. So before we dive into any more code, let's just launch this and show you what we're dealing with. So this is a media collection app, so you can enter in your CDs, books, Blu-rays, DVDs. You can enter all that media here and create your collection. It's got a drop-down box to filter by type, so if you only want to see books, it'll show that, or you can go back and show all. I can select items, I can edit it, or I can delete it. If I don't have anything selected, I can add items. Let's hit edit. And one of the other cool controls here is this teaching tip. So what you can do with a teaching tip, by default, it'll show every time, but you can add a user preference to save whether the user has already seen this tip. So once they've seen it one time, you don't show it to them again. It's just telling them how this drop-down button works. So they can save and create new or save and return once they've made a change here. So let's say this is no longer in my collection. I've loaned it to somebody. So now I can hit this. I can either save and create a new item, or I can save and return to the list. Let's create new. And we'll add an alien movie to our list. A video. Let's say it's a Blu-ray, and it's in our collection. Now I can save and return, and we've got all 4 items here. So let's take a look at some of the code for this and see how this works. So in the main page, we've got separate grid for the stuff at the top. So in the top, we've got the header. We've got a stack panel that stacks horizontally for the label for the drop-down box that filters by type, and then the combo box itself. And this is using data binding. So we can bind to things in our view model to show them in the UI. So I'm binding the list of items to this list of mediums in the view model. And then I set the selected item based on that property. And then for the bottom part, I'm using a list view control. And inside the list view, I have both a template for the header and a template for each item in the list. And you can see for the styling, we're using theme resources. This will make sure it'll pick up the light and dark mode or any other color changes that the user makes in their system. If you wanted to instead brand it to your own company colors or something, You could hard code or create your own theme based on your company logos and things. And at the bottom, we have another stack panel that's got the buttons. And these are both regular standard buttons, and these are binding a command to the view model. So the command is what's going to be executed when the user clicks on there. So it'll go into this add edit functionality or the delete. Let's take a look at the view model that corresponds to this. So if you've done any XAML development and used model view model, you may have done your own implementation of an observable class or a bindable class. I'm using the MVVM toolkit, which is part of the .NET community toolkit. It's open source, available up on GitHub. You can get references into your project through NuGet. So if I look at our NuGet packages here, let's see, I've got the MVVM toolkit, and these are all other standard WinUI packages that you'll have here. So by using the MVVM toolkit, it reduces a lot of code that you would normally have in your view model. All I need to do is make my view model a partial class and inherit from observable object. And by doing that, it's going to create, it uses source generators to create another partial class with the implementation of all the public members. So for a property, I only need to create the private member, the selected medium in this case, and when it builds and runs, it's going to create a public property called selected medium with a capital S. So anything that's decorated with observable property will create a corresponding public property for you for data binding. And I can also, if I go down to my commands here, so I've got, here's the add edit. You see this is private and it's just called add edit, but I've got this relay command decorating it. So that creates the add edit command that's public. That'll be bound in the main page here. So this add edit command is created by the source generator. And then within that command, it calls this private method. So when I hit the button, all of this executes. And if I hit delete, this is the code that gets executed. And I've got some code to validate whether the delete button should be enabled. Anytime that this can delete item is called, it's going to check if there are any selected items. So I can only hit delete if there's an item selected in my list. Let's take a quick look at the item details view and view model. We'll look at the view first. We'll go down to that teaching tip. So here's the teaching tip and the split button. So the split button has the drop down with the two buttons inside of it. And to show those, it uses a flyout with a stack panel and the two buttons inside there. And the teaching tip here, we just data bind that to the save button, and that will attach it to that. And in the back here, we have some little bit of navigation logic so that when we open up here, we're setting the teaching tip. This is where it's, if you had some local settings, you can check whether the user has already viewed that teaching tip, and you can set whether it's visible or not. I just have it hard-coded to false so that we'll see it every time that I do this demo. And the other bit that's important in the code behind here is whenever we navigate to this page, we're just populating the initial data if there's already an item selected. So if there's an item ID, then we're going to be editing. If there's no item ID, then we know we're adding a new item, and we should have an empty form. So that's the basics of some controls. Let's jump back to the slides and get to another demo here. So the next one will be the using the Windows Community Toolkit. So there are different community toolkits available from Microsoft that are open source. There's the .NET Community Toolkit I mentioned with the MVVM stuff in it. The Windows Community Toolkit is some Windows specific stuff. You can use the things in there for UWP, WinUI 3, and also Uno platform. So there are animations, triggers, behaviors, controls, and other helper classes in the toolkit. It's open source on GitHub here. There's documentation on Microsoft Learn about the controls and things in the toolkit. And there's a gallery app on the Microsoft Store. We'll take a look at that quick. I've got that open here. So within the gallery, you can explore everything in the toolkit and see things working in the UI to see how they look. So if I go to items view, so it shows you what the items view looks like. It's running live here in the app. So if I expand the source code, it shows me the code that was used to create that. So you can copy and paste from here to get started quickly. It shows you the XAML code for that and also the C# for any stuff in the code behind. And with some of the samples in the toolkit app, you can change some properties to see how it will look in different layouts. So it's got 3 different layouts that you can pick from here. You can change the amount of space between them and space these out a little farther. And we can change the selection mode for this item. So right now it's multiple. I can select multiple items. You can change that to single. So the checkboxes are gone. You just select one at a time. So let's take a look at a sample app that's got this in it. So I've got a community toolkit solution here. And you'll notice for some of these solutions, I have both a solution and a solution X, SLNX. Some people are calling these slinks files. It's a new solution format that's currently in preview. It works with the Visual Studio 2022 preview version. And these are a lot nicer to look at if you ever opened a solution file and you've seen all the GUIDs in there. The solution X files have no GUIDs and they're much simpler to look at. We won't demo that here, but you should go check it out. So here I have a hardware supplies app. Let's run it first to see what this looks like. Call it hardware supplies, but it's got a list of hardware items and then another color picker control here. So you'll see I've got a data grid with some hardware items in it. In this control, I can resize the columns nicely, like basic data grid functionality. And you'll see I've also got a little shadow around here. And I've got some text here with a shadow on it. And my color picker control, I'm using data binding to bind to this shadow color. So if I change the color that I've picked here, it changes my shadows in real time. Anything I change there changes. You can change the type of selection. And that's one of the controls in the community toolkit. Let's take a look at the code for this. So in our main window, there we go. So I've got the mica backdrop on here as well. And for the drop shadow, using an attached drop shadow from the toolkit, I named it Common Shadow. And I'm binding that to the color picker and setting the path to color. So that's telling it to pick up the color property from the color picker and use that for the shadow color. And then down here, this header content control, that's that was the header at the top. And I've got a drop shadow panel, which is also binding to the color picker to pick up that shadow color. And this is my data grid. All I'm doing here is binding the item source to a list of hardware items that are hard-coded in the back code behind here. Just got some code to add a bunch of items to that list. And then finally, we've got a grid at the bottom that contains the text block for the final shadow. It says, I love hardware and all related supplies. And I set the effects.shadow property to the common shadow that's up in the resource at the top. And finally, the color picker. It's got a lot of different properties you can set. So I'm setting the spectrum shape to a ring. You can enable and disable some different things about whether you want to have the different sliders and other picking elements available. And then I'm setting the default color when it launches to be my system accent color. So whatever the user's system accent color is in Windows, that'll be the color of the shadows when you first launch. And in the code behind, like I said, there's just the hardware items, and then we've got the code to set the title bar up. All right, let's move on to another demo here. We should have time to get to a couple more. Notifications. So the notifications API in the Windows App SDK lets you use toast notifications in Windows, and there's a couple different types that we can create here. Let's pop open that demo project. And most of these demos are adapted from samples in my book. I've got a chapter on notifications that I pulled this demo from. So we've got the media collection app again, but it's been enhanced a little bit. Let's launch this. We've got a couple of extra buttons at the bottom when this opens up. So we don't have the special title bar here. It's got the standard title bar that you get out of the box, but we do have some new buttons down here for notifications. So we can send a notification, or we can send a notification that will also have a text box for a reply. So let's try the initial regular notification. You can see it pops up a toast. And if your app is behind something, I can click Open App and it brings it to the front. And I get a pop-up saying we received this notification to open the app. We'll hit OK there. I'm also using a status bar to show the current status. Last thing that happened was notification was received. The next notification we'll send will have that text box. Here's our toast. And now I can enter a reply. So I've received that. If your app was in the back, it would have brought it to the front again, but our app was at the front. Here's the reply. It says input received was hello C# TV. And we click OK there. So let's take a quick look at how that code is implemented, but there's a link in my list of links in GitHub that points you to the Microsoft Learn article that could walk you through all of this step by step. So we have a few extra classes here. Let's go to the helpers. We've got toast with text and toast with avatar. These are two different, they're like templates for creating your toast. So here when I send the toast, I'm adding arguments for the different scenarios I have. I'm telling it to use this icon, cropping the image to a circle when it appears on the toast. Here's the text that'll appear on the toast. And this is the text box. We're adding a text box to it. And this is the pre-populated text that will show in the text box for the user. And there's a button. So the button on the toast says reply. and the action is reply, and that's what we got back in the message that appeared on the screen. If we look at the other one, the one without the text box, it looks pretty similar, but we just go from text to button. We don't have the text box in this one. And then we've got a notification manager. This is where we register to receive notifications. So in the initialize here, we're setting up an event handler to find out when notifications are invoked and calling this register on the handler. When messages are received, we're going to process them here. You're going to send the notification out to Windows. And then this is this notification shared. These are all the updates that we received in that status bar. So the status bar in the app gets updated based on which one of these we've called from the manager class. And finally, notification received. If there's any issues, we just pop up a message saying there was some unrecognized message that was received. And like I said, this is all out on Learn. This is my speaking repo, but this is the page within this conference's stuff. So I've got all the links for all this. And if you go to the notifications here, Windows App SDK app notifications. So this overview gives you a little info, but then there's a quick start that walks you through all of this on how to set up the notifications for your own apps. All right, next, we don't probably have time to go through all the interop demos, but there are a couple different ways that you can do interop. So there's XAML islands. So this was added in Windows App SDK 1.4. And right now they're still working on enhancing this, but you can only use the XAML islands to show Windows App SDK WinUI stuff within a C++ app. So you can't use this in other WinForms or WPF apps yet. But there's a sample up on GitHub from the team that shows you how to implement this in a C++ app. And I do also have the code in my repo. And we don't have time to walk through the code, but I can run this quickly and show you how it works. Let's run this. So this is a C++ project, and it's within here, it's got a couple of Win32 buttons. These are C++ buttons. And then within there, it's also got some WinUI content. So everything from this toolbar down is all WinUI content. So we've got a web view control that's WinUI. It's got some WinUI buttons, text box. So all of this is embedded within the C++ app. And the other way that you can do interop, let's go back to PowerPoint. So you can use the web view control to embed web content within your WinUI apps. And I have a sample that embeds a Blazor app inside there. So let's run that quickly just to show you what that looks like. So I've got two projects in here. I've got a Blazor project that uses WebAssembly, and I have that running out on the web, so we don't have to kick that off here. This is my WinUI project, and this will just load up our Blazor content from the web. Let's run this. And when this opens, it's just going to be a WinUI shell with your basic Blazor Hello World app. This is what you get when you create a new Blazor project. Most of you are probably familiar with this. This is all running in the web. Take a look at this code quickly. Control Z. So the only thing in here is the web view control, and I'm just pointing it out to where my Blazor app is running online. Nothing else here, nothing in the code behind. It's just loading up the Blazor app. Let's jump back to the slides and see if we can get through a couple more quick things. Deployment options. So there are different ways that you can package your app, your WinUI apps. You can make them framework dependent or self-contained. So framework dependent apps depend on the Windows App SDK runtime being on the client machine. And self-contained apps, when you deploy your app, you're deploying the Windows App SDK runtime with your app. So you have more control over the size of, or you have more control over the versioning of your package that your app has. But the size is going to be obviously much bigger when you're deploying the whole runtime along with your app. You can deploy out to the Microsoft Store. You can deploy through Winget. So up on the Winget repository, you can put your app up there. There's ways that you can sideload. I've got a link here for instructions of how .NET MAUI Windows apps can be sideloaded, and that same process works for any WinUI app. And there are also third-party installers. So Install Shield, Advanced Installer, all those things can work with your WinUI apps. And we won't be able to get into Uno Platform, but I can explain quickly. So Uno Platform is multi-platform solution, kind of like .NET MAUI, but they can also run on Linux and on the web with WebAssembly. So you can create a single code base that runs on iOS, Android, Windows, Linux, just about any platform, all from the single code base. And the XAML used in Uno Platform is WinUI XAML. In my book, in the one chapter where I show an Uno Platform demo, I just take my WinUI code and I copy and paste it into an Uno solution, and it's the exact same code that I can now run on any platform. And the latest releases of Uno also have Hot Design, which lets you drag and drop design your apps at runtime. So while you're running your app, you can open up this designer and make changes, and it'll save those changes back to your project, and you can see them at runtime. And we're not doing the demo of Uno. Final thing here, the WinUI roadmap. So Windows App SDK 1.7 was just released, and 1.8 is up next. They just released the first experimental release of 1.8. The new things in 1.7 were a lot of things that people had in UWP that were missing. Background Task Manager is now available in WinUI. Camera Capture UI, so you can use the camera in your PC to capture images. The new title bar we saw, and the OAuth Manager, so you can do OAuth authentication in your apps. And they're working on a XAML designer. Right now, there's no UI designer for WinUI apps. You have to hand code all your XAML, but they have started work on a XAML designer in 1.7, and they'll continue that work in 1.8. And this QR code goes out to the roadmap for Windows App SDK. And let's see, if we have a minute left, I have one other demo that's not part of the slides, but it's pretty cool. In the current experimental releases of Windows App SDK, there's some AI stuff that you can do. So this Windows Copilot runtime, this project can only run if you have a Copilot Plus PC that's got the local Phi Silica AI model on it. So what this has, let's just run it and you'll see what we've got. So this is going to use the local model on my machine. And if I pop up Task Manager, we can watch the NPU do its work. So here's my NPU, my neural processing unit on my machine. And you'll be able to see the GPU and CPU activity as well as we run this demo. Let's see if we can resize this a little bit to get everything to fit. right. So here I have a prompt, provide the molecular formula for glucose and explain its properties. And we're asking it to please give us some markdown formatting to make it easy to read. So in these APIs, there are different kinds of queries that you can run against the local model. You can do a general query, which is just your usual questions that you'd ask the AI. You can ask it to rewrite your text, summarize text. If you have a multi-page item that you'd paste into here, you can ask it to summarize it. And you can also do text to table, which will create a table of items from whatever you paste in there. But we'll just do a general query quickly here. And it's thinking. And we should see the MPU start to take off a little bit. It's starting to get busy. There it goes. Meanwhile, my CPU is pretty flat, not much going on there. GPU is also not working. Everything's happening on the MPU. And in the code here, I'm telling it to feed the data back to me as it's being generated, so we don't have to wait a long time for the whole thing to be created before I show you the output. We're getting this streamed back to the app asynchronously. So we'll wait for this to finish up, but there should just be a couple more lines, and then I'll show you the code and we'll wrap up. This checkbox to show progress, this is what controls whether it feeds it back as it's going or if it just does one call and wait for everything to come back. And while we wait, oh, there we go, it's finished. The other thing I have here is a checkbox to say use a strict content filter. So that will filter content, has violence filters, has different filters that I'll show you in the code here. Super quick. Let's close that. So here's where I'm checking if we want to show progress. So if we want to show progress, it uses this generate response with progress. And then we've got a callback to show the results as they're coming in. If I want to see everything at once, I just make a single call to generate response async, and I get everything in the result and populate that at the end. The other thing I've got is like I mentioned, content filters. And I've got a thing down here, apply content filters. So if the checkbox is checked, it's setting all these filter options for violence, hate content, sexual content, self-harm content. So all of that can be filtered out with these filters. And this is all running locally, nothing pinging the web for this AI call. So like I said, that's in the experimental release. Hopefully it'll make it out to a stable release very soon. And that's all I've got. Do we have any questions in the chat?
Hi, Alvin. Yeah, we have a few questions. First is a compliment come from Deepak. He said it's really amazing. I agree with him. It was really nice to have those demos there. We have a few. Let's start with Tomar. Right, is asking, what best practices do you recommend for structuring a Win UI app to keep it maintainable and scalable?
So I would definitely recommend using some type of MVVM, whether you roll your own or you use the toolkit. I prefer the toolkit to reduce the amount of code, but I would do that. Also using dependency injection. In my projects, I just use the built-in .NET host for the DI container. And in some of the projects, I've got some services, like I've got a navigation service for doing that page navigation. That's in the DI container. I've got some other services for calling different online APIs. So by using DI and MVVM, those are the best ways to keep your app scalable. I also recommend using the theme resources unless you're branding your app. People like to see their Windows colors and dark mode, light mode picked up automatically.
Perfect. Thanks for answering that, and thanks, Rohit, for your question. Let's take another one from Scott. He's asking, can you explain the differences between various deployment options like Microsoft Store and Winget, and when to use which?
So Microsoft Store, your app will only be available through the store. With Winget, you can make it available at the command line, so people can just install at the command line, say Winget and the name of your package. For enterprises, there are also some enterprise deployment where you can deploy to your workstations through Intune and other enterprise deployment solutions. So it depends if you are targeting, say if you have a consumer app, you definitely want to go to the store. If you have something more focused toward developers, maybe you go up through Winget and then through one of the other installers or the Intune option if you're doing enterprise deployments.
Perfect. Let's take final one that's coming from Khan Singh. He's asking, how seamless is it to use both .NET and WinRT APIs together in a modern WinUI application? Are there any caveats?
Yeah, it can be tricky knowing when to use
Hmm.
what. You can use all of these together. Some of there's some things in the WinRT stuff that you can't use anything that's like you tied to the UI. Like WinRT has a lot of UI specific stuff in it that was tied to UWP. You obviously can't use any of those, but anything else like for file access. So you've got access to the file APIs both in WinRT and .NET. If you wanted your app to be more like a sandbox app like UWP, and you just want to have access to local storage, you would use those WinRT APIs. If you want to have full access to everything, you know it's an unrestricted app. You can use the .NET file APIs. So yeah, it really depends how restrictive you want to be.
Perfect. So uh, okay, do we have, let's, okay, Kamsing says, thank you. Let's take one more question, then we'll just wrap it up, right? I think the question will
Sounds
keep
good.
on flowing as long as you are on the screen. Um, for developers completely new to WinUI and Windows App SDK, what are the first key steps to get project off the ground?
So it's important, I would say, to learn the XAML if you've never used
Hmm.
XAML with WPF or one of the other frameworks, Maui. They're all pretty similar. They have slightly different schemas when you go between WPF, WinUI, Maui. Like I mentioned earlier, UWP is almost exactly the same as WinUI. So if you're coming from there, there shouldn't be much of a learning curve. But without the visual designer, it's important to understand how XAML works. And there are a lot of good resources up on Microsoft Learn, some different books out there, including mine, to get you started. Um, yeah, that's the biggest part. And if you're familiar with .NET, the rest of it should be pretty simple.
Perfect, Kelvin. So that is it. So thank you so much. I think we have a few questions, but I think we'll have to wrap it up. All right, Elvin. Any final words before we wrap up your session and actually this conference?
Just thanks for having me. I really appreciate it. It's great to
Yeah.
get the word out there about WinUI.
Yeah, thank you so much, Alvin, for your time. I really appreciate it, and we all love Microsoft Learn. So thank you so much for maintaining it or having it up there. I often go there for the certifications, or often time into time there are some challenges. So thank you so much for that.
Yeah,
Yeah,
sure. Yeah, no, one other thing that everything up on Learn, all the documentation is all open source. So if you ever see
yeah.
mistakes or have ideas, you can submit issues on GitHub or submit a PR if you want to change something.
Yeah, and get your avatar there on the page. You can see yourself as a contributor, which is super cool.
Yeah.
Thanks for bringing that up, right? I remember even back in MSDN, right, they always had it. So it's good that this thing is open source. I love it. Yeah, Alvin, thank you so much for your time. Have a great day ahead, and yeah, hope to see you soon in some other virtual events.
All right. Thanks, Simon.
All right, thank you. All right, ladies and gentlemen, that is it. We wrap up the two-day virtual conference that was on .NET by CSharpCorner. We returned back after almost 2 years, maybe. It's been a while we did a .NET conference. This was too a short and sweet one, but I want to give a shout out to all the speakers for joining this conference. I know everybody's busy, so thank you so much for taking out the time. Everybody for who tuned in, all the folks in the chats and on the social media, thanks for joining in the conversation and your lovely questions. And also some of my team members. We have Rohit behind the scenes who's taking all the lovely screenshots. I'm gonna, I'm gonna, you know what? Perhaps hold on. I'm gonna say thank you so much, so much, everyone. See you next year at .NET Conference 2026. Thank you so much, and see you at .NET Conference. See the nobody's watching us, so I can take as much time as I want. Yeah, so I'm gonna put this up on the screen, right, and be and keep a very happy face. And that was actually for Rohit, who's doing all the social media, right? He was bugging me to actually post. So thank you so much for Rohit for doing all the social media, Aditi for doing all the graphics. Deepak is up here in the chat. Thank you, Deepak, for being active. I know he was there behind the scenes the other day, helping us with the streams and other live streams that we have. Thank you so much, everyone. That is it, boys and girls. That was your .NET Conference 205. I'll see you in some other events of CSharpCorner. Until then, take good care of yourself and enjoy your day and night, or wherever you're joining us today from. Good luck.